All right. Let's see what we got going on here. All right, we are working on getting the home lab going. Let me see if anybody's on here. There were some questions earlier about if I had the home lab systems up, but they are up for anybody to use. I was going to do some maintenance yesterday and switch some stuff over. I didn't get around to it, so come on, system. What's going on here? Alright, we got one person connected through. That's okay. I can send a message of the day if I'm going to do anything. Robert, how's it going? We are just working on getting the lab set up. We're going to... I don't know, I don't really have a strong plan for what I'm working on today, but I thought about getting one more server. I have one more server to move over from here. Well, I have a few servers to move over, but if I get C router moved over, that's the last one for this server, and then I can start repurposing this server. And then I believe I can actually probably turn this server off. This one's pretty much done with everything he's doing. And then I gotta go look at what I'm doing in each of those and cleaning all that stuff up. Yeah, Wiggly, you're okay. You can use it. I'll send a message before I do anything. Let's see if I can get this reconnected. Seems like my whole lab environment's jacked up right now. Probably because I haven't been in here in a few days. Been working on too many other things. Yeah, you always get that message. Okay, let's then see what's going on here. Got our nodes. Let's just check them all. We have a thing that runs every morning to check them, but let's still hit the nodes. Make sure they look good. We're gonna hit all. We'll go 20. Let's make sure all the nodes are up. Yeah, they're good. Okay. Some of these boxes need to be rebooted. In our environment, we don't really want things up for very long because if changes happen in the back-end system, like the images, we need to reboot them for them to take those. So I haven't made any changes in a while though, but if I had a node like this, wouldn't have taken any of those changes, right? Because it's a stateless node. Which, it's fine. It doesn't really matter that much. It's just I like to keep the environment cleaned up a little bit. Okay. Yeah, I think all in all though, that's fine. We're barely using any of the load on this system. It's not really doing much of anything. Pretty much chilling, really. Let's go to... Okay, so what am I working on then? Let me go... We could start building C router out here. And then we can go from there, or... Yeah, we could do that. We'll start that. That's one. But I need to give him a new name. So I think the name I'm going to give him is actually going to just be Linux router. Because people were asking, they were like, what's C router? What's the importance of the C? And I think I got the C because I think the reason I came up with C for C router was because that was to my back-end compute stuff. And since I'm not doing that, the lab is not specifically compute like a high-performance compute system would be. It is back-end, just Linux systems for you guys. So I guess a name like Linux router is fine. C router doesn't really fit because that's not really what we were using it for. Wiggly said, what's the difference between a server and a router? Well, routers have two functions in a network. There's really only two things a router wants to do: path determination and packet switching. So in my home lab, my system does a very, very base, so C router does a very, very base path determination packet switching. Again, that's the function. right here. So if I were to pull this to full screen for a second, he sits between two networks, right? He sits on the 192.168.11 network at 160, right here. And then he sits on the 192.168.200 network on .1. So he actually functions as the first IP address in that range. And he is the default gateway. And then he sits there and he allows traffic to move through him. If I do a... He has forwarding on for his packets. So he forwards packets between them, between those two interfaces. He also functions as the... I have a static route on my internal router for my home lab that tells anything going to 192.168.200.0/24 to go that way. So that's it. And then a server just serves functions on a network, right? That's all a server does. Now, this is where it gets a little weird because that's a server functioning as a router. But Linux boxes have been doing that since they were invented. So this method I use to turn this into a router, it's a really old way that we used to do it, and most people don't do it anymore. But now we're going to do it on this new lab, so I'm just going to call this Linux router. That's fine. Resource pool, none of that's going to change because it's all the default pool. And I don't think I have to select that, do I? Let's go up here. Create VM, here we go. We'll do it like that. Linux router. Operating system, we're going to do an ISO image, and we're going to use, we'll use Rocky 10 on this guy. Whoops. Rocky 10. Yep. Boom. Linux kernel, that's all fine. System, that's all fine. For iOS because he's single. Yep. Don't see anything wrong there. Disks are fine, but we're going to change the storage. We'll leave it on lab storage, but he only needs... It could be 32 gigs. That's fine. He doesn't need any disk space. We're not going to really do any disk stuff on him. Sockets, cores. He actually doesn't need much of that either, so we'll go ahead and give him 4. And then his memory, we'll give him... we'll go 4096. That's fine. Network. Now so network, he's going to get 2 networks, but we're only going to give him 1 to start. I think we'll add the other one later. This is fine. No VLAN tag to start. And let's go to advanced and see if we can give him a second one. Nope, I can't give him a second one now. I guess I'll have to give him another one after we build him. He doesn't need a VLAN. Nope. That's terrible. There we go. No VLAN for now on his interface. And I think that's fine. We'll go ahead and start him up. He should get a name here in a second. And yeah, we'll start working on that. That cutover will be almost invisible to the users. So we do have one user in there, but I think that's probably Wiggly Mittens. And then we'll be able to get that going. All right, so Linux router, he's not on. Let's turn him on. Start him up. Go watch him at the console. He needs to have, so we need to give him a little setup here. Just install it directly. Yeah, that's fine. We're not going to spend a lot of time in there. Let's also see if we can, while we're sitting here, if we can hook up his extra. Can we add another network? Another network device. We're going to put that on VLAN 1. And we're not really worried about the MAC address for it, but we'll go ahead and add that in. So now we're going to have network device 0, net 0 will be no firewall or no VLAN tag, and then network device 1 will have VLAN tag 1. That's going to be important to us because all these devices that are on that internal network are on VLAN 1. They're on VLAN tag 1. So Rocky's, well, he's not Rocky anymore. He's not C router. He's the Linux router. He's going to sit between those two networks. Yeah, Wiggly Mitten, only on the one server. The one server does all the forwarding between them. Yep. It's one device to function between the two networks. Yep. He's going to be the only one that can do it. If he's down, the whole back end network will be down as well. Failed Doctor said, "Hello, Mr. Streamer. What's an alloy and why do we need node exporter?" All right, so it's actually a funny name. If you're so alloy and node exporter both feed up metrics from your servers, and you don't need anything, I guess, in the world. But if you need them in an environment, what you need them for is to feed data over into Prometheus. They push up data, and then Prometheus can scrape that data and then show it like this to the cluster, right? This is actually not node exporter. This is all node exporter here. So this is a node exporter. And then we're going to replace that with Alloy, because Alloy is a newer version of the system. So a newer, more modern way of doing it. And yeah, more modern way. All right, let's pull this up here. Ah, we got a kernel panic. So let's go check. There should be, let's shut them down. I know what it is. It's the processors here. They can't be anything but host. I'm not sure why they have all the other options if none of them work, but that is a limitation on at least this version of Proxmox that I'm on. Oh, you know what? And I can move this up because I do have that chat. Let's move this over here probably. Yeah. We'll do it like this. There we go. That's probably good. That's weird. All right, shut down. Stop the box. Yes. It's not gonna let us make a change until it's down, but taking a long time to come down. Alright, well that's weird. Now we can't even we can't even select it anymore. There it is. Alright, there we go. Alright, that'll work. Yeah, you have to use hosts. Everything else just kernel panics, which is why I don't even understand why they have those other. I don't know why they have so many options that are all just going to kernel panic. I don't know why they do that, but host is the only one I've seen work since I started using Proxmox. So it's I don't know, like I don't know why would you give options that are all busted? But I don't know. I didn't write their stuff, so I just let it ride. I'm not super worried about that part of it because I do know the workaround, but it's weird to me that like it's not even the default, and then all the other things that you can pick are all gonna just kernel panic too. So yeah, I don't know why they do that, but you know, it's their tool. They can do whatever they want with it. I'm just using it to set up my little router here. So we're gonna get this going here, and then I'm gonna work on the other part. Now I have some notes on this because I wasn't sure exactly how I would do it in this environment. So we're gonna use some notes and check it out. But let's see. We'll let this build. We don't normally one-off build servers. Most of the stuff in my environment is all, you know, images, and then we build stuff. But some of these servers that function as what we call infrastructure off to the side of the lab, I kind of expect them to be bespoke nodes, you know, things that we build directly. Let's go ahead and hit continue here. And then we gotta select some of this. We're gonna fix some of this stuff. We'll go ahead and use our automatic partitioning. I'm fine with that. Sometimes we carve those up and adhere to standards, but I'm not really worried about that for my router box. Network and host name, I've got 2 networks, right? And I can set these hard now, so I don't want them to be, let's go ahead and configure them. I do not want them using DHCP, right? So there's no DHCP. We're going to use static. Make this a little bigger for you guys to see. Make it a little bigger for me to see. Shoot. Leith, no, I haven't completely moved over yet. This is the last major one that I need to do to get another XCP-NG box out. So here's where we are at right now. This box is completely done. I can actually turn this one off right now. This one doesn't have anything on it. The last one I need on this guy is to get C router out of the way. That's the router back into the lab environment, and that's what I'm building right now. So I'm building Linux router to replace that. And I was explaining earlier, the reason it was called C router, I think I picked C router because it was back to my compute boxes. But since we're not doing this strictly as a high performance compute environment, it doesn't really matter. Like, I don't have to call the backend servers compute, even though they are just compute. I'm not making that distinction. Red one is there for, he's a lab test environment that's running iPerf for people, well, iPerf 3, and then you could bounce speeds off of him and do speeds for reads and write. But he technically can be shut down right now too, because nobody's doing that particular lab. Well, if they are doing that lab right now, they're just going to be sucking for a little bit. But they can bounce off any other servers if they wanted to in the environment. So it doesn't really matter that I have one server up, because if you know how to set up the servers, then it doesn't, you know, you should be able to run the lab environment however you want. All right, I mean, because it's basically your lab environment, guys. You guys can do whatever. On my internal network, which one was this? Hold on, I gotta go check. This one is, so he's internal. We'll go ahead. You know, we'll leave them empty for now. We'll set these up once we get the box up. And this one's the same way. This is on the 200 network, and he got a default. It's actually funny, on the internal network, Werewolf gave him a way in and out. So we're going to go ahead and modify this as well, and we're going to configure him to also not take that address. Oh, it's not gonna let us pick that. All right. We'll leave that for now too. We'll just let that box come up, and we'll go look at this stuff in a little bit. Linux TV said, what specification does this host have? So if you're talking about my Proxmox environment, the Proxmox system has 512 gigs of RAM, and he's got 80 cores in him. And then this is his usage right now. He's really not being used very heavily. He's running about, I don't know, 20 something servers. Most of them are lab environment servers, so they're not really doing much unless people are on them doing actual labs. So it's really just capacity that's ready for users. We only have right now, we only have one user in the environment now. It's me. I'm on there, but then, you know, I can do whatever I want. And then one person's passed through our bastion. That's what this Prolog user is right here, right? And then most of the time we just kind of keep an eye on, you know, how many users are trying to get in and do ratchet shit in there, right? Because this is all the users. God, there's a lot of them right now trying to get in and do whatever before they get themselves banned out. All right, let's not worry about this for now. We do need to set a root account. I'll put a root password. We'll use my general lab one. Just a little BS lab password I use. Date and time is Phoenix, that's fine. Software installation is not going to be a server with a GUI. We're going to do just a server. And then we're going to come over here and we're going to modify just a few things that we typically add. You can set these packages also. You can do this stuff automatically later. But for me right now, I don't need any of these. I tend to do security tools and system tools just in case I need them. But we can add most anything we need to later, so it doesn't really matter. We'll leave the network as it is. Let's check this right here. He did get an internal. Yeah, he got an IP address. That's fine, because then he can update himself. User creation. For this guy, we'll leave a Scott user on there. We'll give him a basic little password too, just in case we need that. We'll go ahead and let that start installing in the background. 70 gigs of RAM is not much. No, 70 gigs is not all that much, but he's got 512 gigs of RAM. So he's okay for a server. I'm trying to look at what you're talking about here. That's how much memory's in use. He's got 512 gigs of RAM, but yeah, he's not using that much. I mean, the box, that's what's allocated, by the way. Let me show you guys the actual usage of this box is like they're waiting to use that memory, but his actual memory usage is, yeah, he's not using hardly any of his actual RAM. And if you go down and actually look, yeah, he's not really using it. Those boxes are just holding it open. So yeah, that server's chilling, just chilling in there, drawing power, turning power into electricity, but he's not really doing too much. So all right, let's watch this box build. We don't need to really watch him build. Once he comes up though, we're gonna start connecting to him and configuring him the way that we want him. And then there will be a little bit of cutover time. So I will send a message. I'll do something like this to all the servers. This will be probably something like echo. The server is the environment is going down for maintenance in 10 minutes or something like that. Right? Yeah, something like that'll work. Oh, no, hold on. There we go. Better. Yeah, that should send echo the environments over maintenance to wall. Yeah, and then that would wall all the boxes or whatever. That's kind of the way I'm doing it. Xshunya, how's it going? That's what we're working on right now. I'm also kind of like waking up still, kind of beat. Got the grandbaby in town, so he's running us kind of ragged around here, being a kid. Xshunya's have been away from the Discord. What I missed? New courses, werewolf. No, I haven't started the werewolf courses yet, Xshunya. But what you've missed if you go to Discord, I wouldn't say you missed anything, but we do have, right? Discord's free for people. We're almost to 5,000. We're real close to 5,000 users, by the way, which is kind of cool. Actually, let's see how many we got here. Looks like we're at, yeah, 4956, so we're getting there. Mainly what I would show you guys is if you go to events, you can see what events are going on. All the events are always free, but Linux from Scratch is coming up today. I think they canceled that last week, but they're basically going through this process of building a Linux kernel, building your own little Linux operating system if you wanted to, if you wanted to see what it looks like to build one of those out. What I tell people is this is an excellent thing to go do. Like Colchis is running that. There's a lot of people learning a lot of good stuff in there, but some of those skills, while they're very valuable to know how to troubleshoot things, some of those skills aren't going to really serve you well in the enterprise. Like you're not building a kernel professionally, and you say, wait a minute, I thought I'd be building kernels all the time. No, because in the enterprise, you're working on a fleet of servers that are supported by some other vendor typically, so you don't get to do all that cool stuff. Cool stuff like this, you get to do in like groups and hanging out with buddies and doing it on your own. It's just like if you were noodling around on your own vehicle at home, but when you go into work, you have to work on like a fleet of like Ford F-150 trucks. You don't get to just switch out those engines whenever you want. You got to keep them running. It's the same thing in the kernel world of the Linux environment. If you're doing Linux professionally, you're just keeping stuff running. And you say that sounds really boring. Yeah, but it's good pay for boring shit, and then you do all this stuff on your own time for fun, right? So anyways, my point is that's there. Bash study groups every week, and we're also doing Wireshark study every week. Yesterday we mostly just watched videos and went through like how we use Wireshark in the industry and that kind of stuff. So that one's good. We've been doing that one for, I don't know, probably a few weeks now, and we've been getting through the study certification. Like if you wanted to go take your certification, most of us doing Linux, we don't necessarily care about having a certification. Like, I don't really care about a Wireshark certification, but the body of knowledge has been really good. Like, we've been like going through this tool that most of us have at least played with, and we've gotten, I think, pretty good at like using all the different pieces of it and stuff. So that's something that we do. And then coming up in August, we've got our big technology conference. So this is a free thing where there's just a bunch of speakers that come in and talk to you guys. So yeah, that's all you missed, Shunya, all that stuff. Let's not send this yet. We don't need to do that. I do have a plan, Shunya, to do, I have a whole high performance compute course that we're going to work through, but it won't be specific to Werewolf. We will be doing Werewolf in the course, but that's not the whole point of it. So anyways, that's kind of, hopefully that answers your question. Also, I realized just a little while ago, I was like, wait a minute, we got Monday off, but I got a college class on Monday night. So typically I would cancel the college class because that's, it's a holiday. So the college class will be canceled. But then I got to think about it. I'm like, since it's an online class and the students just watch my recordings, I might just record it that day anyways. And it'll be there. Yeah, Shunya, Wireshark's pretty big. Yeah, you can, if you're, especially for people that want to do network engineering, you got to know your Wireshark stuff, right? But then us on the Linux side of things, we all touch networks, right? I don't have a single Linux box in my environment, right, that isn't touching some type of network, right? Like everything's touching a network in some way. So we have to understand what's going on. Like I often show Linux engineers and Linux admins the bare minimum that I think you need in the networking side of things. So that kind of stuff. Yeah, actually, yep. And I need to get GPUs into our environment. I just haven't gotten around to it yet. I got the authorization from the wife like a year ago to go buy one of those little digits boxes, and then I just never did because they didn't come out. And then I think they came out this year, and I just haven't prioritized it. But I do want to get one of those little digits boxes and connect it up to the lab so we have that stuff. We'll get around to that, I'm sure. All right, Linux Router's definitely taking its time building, so we're not gonna focus on him too much. We're not gonna wait for him. We'll let that build in the background. The other thing I wanted to do today was I was gonna highlight. I had talked to Zorgel, one of the guys in our server, and he built a pretty good lab for how to deploy Grafana with Alloy. And I did it the other day. I did the lab, and I was like, this is a pretty good lab. So I was going to show you guys how to do it, but then also we were going to start to plan in the home lab how to move off of Node Exporter. Because if you go to our environment here, right, and you like SH to Rocky 5, let's say, and then you go to systemctl status Node Exporter. Oh. Then you've got the Node Exporter running on the box, right? And you say, all right, Scott, what does that mean that Node Exporter is running? Well, it means that we're exposing port 9100 on our server, and in that 9100 port, we have a path for /metrics, and that is everything that Prometheus wants to see when it scrapes data out of your server. So watch this real quick. So I curl 127.0.0.1, which is my home lab, on port 9100, and I go to the metrics path, and it'll just what 7001 9100. Oh, metrics, guys. Here's all of my metrics for my server, right? So all I did was this, and let's say I wanted like RAM. I could just get all the RAM information that my system is sharing out or whatever, right? Well, then Prometheus comes along and scrapes this, right? So for people that haven't seen this, go to Prometheus. In this environment, etc Prometheus, and then I look for, I think they're called, I think it's lab.json. Yeah. And in here, there's a server, and we could go find his name. Well, actually, it's by IP, right? Because it's the label. And, whoops. Here is, what were we on, Rocky 5? Probably... Oh, he might have his own. Huh. Maybe he's got his own. Where do I have him? I actually don't know where I have him. 54. Where's find that? It doesn't matter. He's in there somewhere. Because if he wasn't in there, we wouldn't see him over here, right in our lab monitoring. Where? Actually, no. Look, I don't even see Rocky 5 in there. That's wonderful. Anyways, it doesn't matter. Point is, that's how my system knows to go scrape those and then show it, right? And really, if we cared one more step for people who haven't done this before, he is 192.168.11.193 in my home lab. I can go query the data directly from him if I wanted to. I can go to that address on port 9090, and I can see my Prometheus stuff, and I can just say, well, are the servers up, right? I can just say up. And I say query up against all the servers in my environment, and I can see if those nodes are up here. All the nodes in my environment. And there's 155, which I believe... He's just 55. So we can look for that. Apparently I don't have one for him. That's embarrassing. Let's go make it real quick. Well, I can make it a few ways, but I could have sworn I had a Rocky 5 in here. Let's just fix lab.json. 52. So we only see these ones. Let's just go YYP and make that a 53. Oops, R3. And then we'll P, and we'll change this to an R4. And then P, and we'll make this an R5. I don't know why. Yeah. Restart our Prometheus real quick. Let that service come back up. We'll rerun our up here. And then when that scrape happens, we'll see the 54 through 50. Yeah, here we are. So now we see those servers. And then over here in the lab monitoring, now there's the 5. Because I was like, where the hell's 5 at? He should have been there. Rocky 5 is now there. That was not there a few seconds ago, right? So the point is we can monitor. So if you want to see that visually, because some people are like, well, that doesn't make a lot of sense until I see it visually. The way it looks visually is like this in our environment. This is the way our monitoring works in the lab. And all the things I just talked about were some server, any server in our environment is pushing from node exporter port 9100, right? So this is right here. Port 9100. And Prometheus scrapes that and then keeps that all in its time series database. And then Grafana is querying that out and getting that information from the system. Saigama, does anyone have an opinion? That's funny. So we've got all that stuff. We can query and we can see the environment here. We can see whatever we needed to. Let's let this thing reboot. Let's go to hardware. I think we have to remove that disk. Not use any media. Okay, boom, get rid of that. We'll let that box reboot, and when he comes back up, we're gonna go set him up to do the routing stuff that we need. And then let's check if anybody's still in the environment. We do still have somebody through. It might cut them off, so that's why I'm gonna send the message to let them know. We'll go ahead and just send that message now. I had it up here. Let's go find it real quick. I have to go page up. We might run out of buffer here. Oh, wait, did we? There we go. That's what we were going to use. going to look like that and that. So this will send, we'll go to all the servers. Oh, oops. Let's get back out of there. It's here. And then we'll put that on the end of it. That's going to hit all the servers and echo to the wall that the environment's going to go down in 10 minutes. So we'll give people a little bit of time to get out of those servers before we go making this change I'm about to do. While we're doing that, we got to start setting the node up. So let's go connect. Let's connect into them. Let's do the things we need to do to them. So we got to give them a name. Host name. CTL. Whoops. Host name CTL. And then I think it's just set name. I always forget this one. Oh, it's just host name. And it'll be... This one will be Linux router. So then if we exit and go back in, there's his name. All right, so he's got the name right. I can make that console a little bigger for you guys too if you want to see it. So he's got, okay, so he's got incorrect addresses now. We're gonna have to fix that here in a second. But let's turn him on so that he has the right basic configuration for this. So we're gonna VI in Etsy. So in Etsy sysctl .d, we can have any number of files that we wanted to that would be to configure how systemctl comes up, right? Or sysctl rather. And these are kernel parameters. So I'm gonna go ahead and VI a file in here that's just called let's just call it router.conf, right? So as long as it's a .conf and it's in that directory, it'll be read. And we're gonna add 2 lines to it. These lines are going to allow our IPv4 to forward. So it looks like this. It's net.ipv4. So it's IP_forward equals 1. And then if I really had it, I could do IPv6, but we're not really using IPv6. Forward equals 1. So now if I do sysctl-a grep4 that, it's not going to be on. So IP forward, right? We don't have those turned on right now. See how there's 0 and 0? Well, we don't even have the one for IPv6. So they're all zeros right now. But I'm going to reboot the box real quick. And when it comes back up, it's going to read those parameters, and those values are going to change. And we're also setting what we call the persistence. I'll go ahead and let that start. We're setting that to be persistently coming up. And then we're going to go ahead and check if the firewall's on, and if the firewall's on, we're going to set some values to allow us to forward traffic. Now, I don't know how to do that with net filters or NF tables. I've never used that. I've always used IP tables, so I'm going to actually use some notes that I have here on it. So let's set root. Let's get in there. If I do my sysctl-a and grep for IP_forward, we'll see that now that's turned on. You see that for IP forward? Yep. Okay. So then we want to do a systemctl status. We need to check 2 things. Firewall D, that's on, so we need that on. And then the other thing that we need to do is we need to do a git enforce and see if, okay, so Firewall D is running and SC Linux is also enforcing. That's fine. I don't really worry about that part of it. Now what we need to do is we're going to set two interfaces, so IP, BR, ADDR. We've got an internal ENS18 and ENS19. I don't really like those names, so we do need to fix those names. But we'll be fine with that for now. Let's check one other thing. What is that command? nmcli con show. Yeah. ENS 18 and 19. Oh, okay. Yeah, I guess so. All right, so let's do firewall CMD. Firewall And actually, see, I don't like doing configs like this directly in a console because it's hard to see for everybody. It's hard to see for me. So let's connect to that box directly as it actually exists. So we'll do it like this, even though this is eventually going to change here. But let's SSH to 192.168.200.42 because that's the address it has for now. And then not going to let us connect. All right. There's a reason it's not letting us connect. vi etc ssh sshd underscore config, and then / to root. And see, root is, nope, that's not it. / capital root. Root cannot log in because password is prohibited. So we are going to comment that out, and we are going to change that to yes, just for now. We can, actually, I'll show you guys. This is a better way to do this. Escape : Q, don't save it, go back in there. We're going to YYP, and then we're going to change a different line so we can leave the default line there. And I'm going to say yes for the password so root can log in. Systemctl restart SSHD so it rereads the config, and then now I can immediately log into that box, right? So that's why, if you ever wonder, oh, I'm trying to get in the server, but I know it's IP, I'm getting a prompt back, but I can't get in, especially if you're using the root user, it's almost because it's always defaulted to turned off in modern Linux. So anyways, now we're in the Linux router and we can see it a lot better. IPBR, ADUR, you guys can see the interfaces we're working with, ENS 18 and 19. So we're gonna set those. Let me see real quick. NMCLI set name for interface. I want to change those names just so that there's like a different way. I want to see if I can see a better way to. Let's go. Let's try this real quick. The connection ID is ENS18. So I'm going to try this command. I don't know NMCLI nearly as well as I do the older stuff. Let's go to the old connection name, which was that. And the connection ID, which is also that. And the new name, let's go ETH0. Oh, hold on. That's my bad. Yeah, that's more of what I want. Okay, we'll do the same thing with 19, and we'll make him ETH1. Yeah. Okay, so we want ETH0 and ETH1. I prefer those for my normal configuration. So let's get that out of the way. And then what we want to do is we're going to change the way that the firewall is working. Firewall-cmd is our command to do that. We're going to do permanent. So that's going to change the backend configuration. And we're going to set zone external to what's going on? There we go. Change interface and ETH0, right? And then now we're going to do ETH1 to zone internal. So in our heads as we're kind of mapping this out, ETH0 is going to be my external interface as far as the when we think of internal external, it's still internal to my home lab, but it's external into my home environment, and then internal is the lab environment where people do all the lab server stuff. So just if you're thinking about it like that, I could draw it out in Excalidraw if you guys want, but it's two different interfaces, and this box sits right in the middle of it, right? And he's going to forward the traffic between between them. The way we're going to set him to do that is we're going to say firewall cmd permanent. If I could spell permanent, geez. Zone external is going to masquerade. Okay, it's already enabled. Perfect. I'm fine with that. And then from the internal, we're going to allow forwarding out. So zone internal, we're going to add forward. Which is this is very similar to what we used to do with IP tables. The commands were just different. So now that's going to allow forwarding, and then we're going to do firewall CMD reload. All right. So now, just name of the config. Oh, you're probably right on that. Let's check real quick. Firewall CMD. Let's check this. I always forget the. We should be able to see the get active zones. Okay, well, as long as the interface sees it, all I care is that the firewall sees it. You're probably right though. The back end name of it's not different, but as far as the firewall seeing it, I'm okay with that. Oh, I see what you're saying though. No, hold on. They are still seeing themselves there. Okay. Yeah, I might need to modify that then. Yeah, because yeah, that's only the short names. That's not really the. Okay, let me see if there is. Interface. Oh yeah, okay. Probably have to go do it in UDev. Yeah, because the public, this is still seeing it here. See, and that's the thing is I tell people I don't know the NF tables nearly as well as I do the IP tables. So I'm just using firewall command to modify those. I'd have to find. Yeah. But just for fun, because I want to see what the system looks like when it reboots. So let's let him reboot real quick. Come up. But that's likely true though. That's not actually changed the way I expect. Also, let's let him. He may have different IPs, so we'll have to check real quick. Nope, same IP. See if we can get in there. All right. Yeah. Let me see. I don't know how to do this in Rocky 10. Let's see here. Should be UDev. No, nothing in here. Wait, do they still do it? Hold on. Sysconfig. Alright, they don't have that. I think, Big Dog, you might have to set the links in the Discord and then I'll pull them up. But I could set them. It says that I can give specific names with systemd links. I haven't done that before. That doesn't look terrible. I'm looking on the CIQ pages real quick. We can set the UDEV rules by MAC. I don't need to do that. Let's try this one. I never tried IP link set like this. And then ENS18 down, right? And then IP link set ENS18 to name ETH0. And then IP link set 19 down. I know I have to do it over here. By the way, I should lose my connection when that happens. Yep, my connection's down. And then set 19 to ETH1. And then I set the interface up. IP link set. Now it says those are reset. Oh shit. Okay. Firewall. CMD. What did we look at earlier? Get active zones. Looks better. The other ones don't really exist anymore. Oh, there we go. Okay, yeah. So that's better because we expect that. But now we need to reset those back to what we had earlier. So permanent zone external is to change interface to that. And then the other one, internal. That's what we expect. And let's do our reload just to make sure. Alright. That was more trouble than it was worth, but at least, I mean, that's something. I've never used the IP link set. I use this doc here directly from, so Rocky is owned by CIQ. Some of you guys know that, but that's the article that I used right there. So, okay, cool. We don't need to set up DHCP or DNS, and we're not going to forward them. You never forward those over networks. Well, I never do. But that's that. Yeah, okay, yeah. No, I appreciate that, Big Dog. Yeah, that actually was... because I don't use NMCLI very often either. And I guess in the newer way of doing this, I need to know how to do that. So that's kind of a good catch there. So, okay. Oh, one other thing on this box. DNF update. We need to update it. Let's see what kind of updates it wants to do, right? Because it's a Linux server that's built off of Rocky 10, but an older version, so it's going to get some kernels. There's going to be quite a bit of updating whenever you use an older ISO. Now, obviously, the ways you can deal with that is you can always pull new ISOs, but most of us don't like to do that. So I would rather build a box one time and then keep a golden image moving forward. But that's really kind of up to you guys how you want to do that. Yeah, okay, we'll let that run. No, I didn't end up doing UDEV. I ended up doing, there's a link right there. I just used the IP set link. And then, yeah, I just did IP set. Or IP link set. And then I could rename it. These are actually the commands right here that I used. Turned them down. This is why I had to do it at the console, because I wasn't going to have network once I did it. Yeah. Yeah, I could forward DNS. Yeah, but in the home lab, I give everybody, there's two DNS resolvers. One is my internal network, and then 8.8.8.8. That's what all of these devices. So we'll leave that going. Oh shoot! Well, we can hop out of here. I think I can get over to Werewolf. It would just be doubled into werewolf here. SH like Rocky 5, let's say, any of these servers that I'm on, and then my resolvers are, yeah, my internal, that's my internal router as a DNS, like an internal DNS, but he doesn't cache that much stuff. And then 8.8.8.8, which is Google, right? Google caches pretty much everything, so yeah, that works pretty good. That will not persist over reboot. That's probably true. We'll let that. We'll let this update, and then we'll go see. But yeah, if I have to set it in UDEV, I can do UDEV rules too. That same link will show me UDEV rules for anybody that wants to. It does say right there it won't redo. Yeah, we can go set them in UDEV. We just make a persistent rule, and then give it the. We just need the MAC address. We can do that. Because we don't have any rules in UDEV right now. We'll go check that here in a second. That's fine. That'll be good. Yeah, we do need it to be persistent, so probably one of these. Let that go. System link. All right. Check in a second here. It's gonna take a little while to update this guy. All right. Give that a second here. He's gonna update. Yeah. Just Mozart, how's it going? Yeah, we're just cleaning up the home lab a little bit. I'm gonna flip this over here in a second because the people that are connected in currently will lose. We don't have anybody connected in right now, so that's fine. They're gonna lose their connectivity for a couple minutes when we switch this router over. So we're gonna let him come back up, and then we'll let him finish patching. Then we'll reboot him, and then we'll come around and give it the old college try here. And yeah, that is going to be good. We do need to set him to be persistently named, so we're going to have to set it this way. I'm going to go I'll build these commands real quick while we're here. This is what it's going to look like. So I'll just go here. While I'm waiting, I'll go grab a new one of these, and this is going to be my command, but I need to set this for two. I have two. One is going to be ETH0, and the other one is going to be ETH1. Right? Those are going to be my two rules. And then their MAC addresses, I can pull them. Even while that server's doing other stuff, I can go pull the MAC addresses right here. So I know the MAC addresses of the internal and external interface from right here. So network device, this is my internal one. And grab his MAC address. That's right there. That's the internal one. And then the external one. Oh, wait, hold on. Nope. Hold on. That is the correct internal one. And then the I'm saying this backwards. There's my other one. This is correctly the internal one down here, and this is correctly the external one to the lab environment here. And then attribute address. When they say address there. We don't need to do this because we're going to be rebooting it. Okay. That's what we're going to put in there. Technically, we have access to that box if we wanted to, so we can, as soon as that's done. I love that the IP happened to be 42. UDEV rules 70 persistent .conf, right? It doesn't really matter. It doesn't actually matter what we call it, but we try to be consistent. Top rules. Drop in our configs there. Subsystem net action drivers address name ETH0 and ETH1. Okay, so now that's there. So then when this is done, well, we can reboot it, get our connection back, see if it comes up correct. Just Mozart said, am I familiarized with AI for coding? No, I am not a coder, not strictly speaking. I have to reboot anyways for the kernel, so I'm just gonna, but you're right, I probably could have done it without the reboot. I could have done, there's a little command here for udev control. I don't do this one ever. But since I care so much about it being persistent, I'm just going to reload the whole server. And then that'll be, let's see this at least come up here. Also, I'm getting spoiled because on my older servers in the XCP-NG environment, they took about 3 minutes to reboot. These ones inside of here, they take, I don't know, 20 seconds, a little less than 20 seconds. Nope, didn't take the names. No, it hasn't rebooted. So it reboot for real. Yeah, it was still up. So it's fast, but it's not that fast. All right, give it a second here. Yeah, Control R works pretty well too. I just I got away from it because if I'm showing you guys in Killer Coda environment, if I do a Control R and I'm in a web browser, it reboots the whole, it like resets the whole environment. So I stopped doing a lot of Control Rs or Control Shift Rs. Oops. Nope, still not taking the names. I wonder if it's because I used... I wonder if it's because I'm using the capital. I wouldn't think that would matter, but... I mean, it definitely matters in Linux, but I would think that... Give it a shot anyways. The other one here, B6. Oh, what am I missing here? I don't know what that is. I don't use IPv6 in the home lab, no. Mainly because I just haven't bothered to set it up. Let's try this. Give that thing a shot. Let's go check. I mean, I'll take it. Let's reboot this guy one more time, though. Because now, if those are correct, then that also shows us then that we do need the lowercase like that, which I guess makes sense in some ways. I would have thought maybe when it parsed it that it took it with the right names, but that's fine. And then a lot of times we've been taking all this and putting it in. We've got one of these here for. We had one of these that was just our home lab rebuild, and C router to Linux router switch over, right? And it was build out a Rocky 10 system, set sysctl values for IP forwarding. So we can go grab these things that we did later. Fix interfaces for ETH0 and ETH1 convention for set the IP. Set the okay, and then this is going to be, you know, inside of here. It would be whatever we did. That's fine. Whatever. It's just for our notes. It doesn't have to be perfect, right? All right. And also sometimes when I do this, I'll grab the actual little document that we used. So then if we're trying to figure out what the heck we were doing later, we're like, oh, that's the thing, the whole lab. These were all the steps that we had kind of done. Yeah, home lab notes and changes as we were setting up and moving everything over into Proxmox, right? These were all the different things that we had kind of worked on or fixed or whatever. So this is just more stuff to add to it as we go. Makes the next rebuild faster, you know, presumably. All right, so now if this is ready, right, and if we're good for that, then the next thing we need to do is we need to slide these two. So this is where there's going to be a blip in the system, right? C router is currently sitting out there doing the work. He is sitting in, where is he at? He's right here, and he is sitting on 192.168. 192.168 11.160 on the external interface as far as this goes, and then 192.168 200.1 on the internal interface, and he's forwarding traffic between the two networks. If this one's able to handle that work, we have to put his IP addresses to those values and then turn this one off and make sure that he can convert between the two interfaces. That's pretty much our next step. And we're just going to do it live. However, there's nobody in the home lab environment right now, right? Like I could watch W if we cared. Nobody's in the environment right now. Nobody's connected through our bastion into the labs, so I'm not really kicking anybody off when I do this. So let's go fix our, let's go fix that real quick. So we'll say nmcli. Let's set these real quick. We can just change the interface. So we'll do it on the actual device here. We won't do it when we're remoted in, because we're going to lose the connection to them anyways, right? Well, he might. So, all right. So he doesn't have any configurations on him right now anyway, so that's good. He didn't take any configurations. So let's try this real quick. We're gonna add in, so nmcli con mod, right, or modify if you prefer. And we're gonna go to ETH0 as first, right? And IPv4, and we're gonna make his method manual, right? And then his IPv4 address is going to be the address we want to use for his, and then this guy's going to be 192.168.11.160 internally, right? He's going to be a /24, and his gateway is going to be 192.168.11.1. Okay. Now the other one, the other interface we're going to do is going to be ETH1. That's his internal. Going to be manual. His IP address is going to be 200. Oh my gosh, I can't believe I just did that. That's 24. And that should be .1. And then his gateway is going to be 200.1. Okay, I gotta go fix this one because I can't believe I did that. 4. Yep. Okay. And MCLI con up ETH 0. Oh, those guys are getting. Mismatches interface name. That's not right. Hold on. Well, that's not good. Should be. Maybe we busted everything. It's very possible we busted everything. Okay. They definitely got those things loaded. We've got that up. No, we don't see any errors in the interface. Yeah. They don't see their devices. But they're definitely the right, or they should be the right MAC addresses. Let's see. Those wouldn't be seen. Opinion is AI. Yeah, I think AI is great. I mean, I think people are using it for all kinds of cool stuff. I mean, I think somebody still has to make a decision when you're building stuff and running things, right? I don't think AI is going to be given the full power to do that in companies for quite some time. If it is, maybe in some like bleeding edge organization, but I don't think like for stability purposes that a lot of companies are going to go that. I know the government's not going to go to that for some time. There's still going to be a person pulling the trigger on command somewhere, probably universally, I think, but could be wrong on that. I've been wrong before, but yeah. Let's see. Why isn't this seeing? Let's see. What's going on with why not seeing those rules? Let me just con list, con show all. Is it there we go. E0. Oh, do I need to set? I don't think I should have to set his Mac in here. That's all fine. Yeah, the connections do seem to have the interface name of ENS18. That's kind of weird. I mean, I guess I could reset the name like I had done before. That seems... Let's see if I have my firewall command in here still. Interesting. So, my connections show that. Just for fun, I'm going to change this. Even though I think that shouldn't work. Yeah, that shouldn't work. Now I need to set that. Alright, we just set that name like we did earlier. Let's go back up, find it. I definitely set that. Now the connection interface name is the same. Interface name, huh? Hold on. Con show ETH0. He's still seeing an interface name ENS18. Interface name is still set over there. Yeah, but I should be able to still see. Yeah, so why does it have, but if it's taking those connection. I can set this to 18. If I leave it at ETH0, it does know about that. That seems weird. See, it's taking, yeah, it's taking my config here. It does say matching interface name, but let's see. Says they're disconnected. Sees them there, but not to a device. Alright, so nmcli con mod, right? nmcli con mod. So ETH0 is going to get connection dot interface name of ETH0, right? Oh, interface dash name. Maybe. Seems like it shouldn't take that long. Now it's going to see a different device on the network, so let me turn that device off real quick. C router has not been down on purpose in a long time, so. Okay, there we go. So he couldn't have it before because it was being used. Now we're going to change ETH1 to ETH1, which still seems ETH1. All right, so now IPBR. Good job. I appreciate that, big dog. All right, so we've got those interfaces that we expect. And if everything else is correct, so if that's also forwarding in between them, like everything else should be correct on there, what I should be able to do is come over to this box, right? And I'm going to do my bang SSH. So he's going to connect into himself. He's going to go into the bastion. And in the bastion, he's going to get a set of options here. You guys have seen this before. And now I'm going to go to the admin course, and it's going to jump me over to Rocky 1. Nope, something busted. So something's not connecting between these yet. So let's see, from this box, can I ping 192.168.11.160? I can ping him. Can I ping 192.168.200.1? I can, so that's going through. And can I get to 200.55? That says packets being filtered. So let's go back over here. Let's check firewall, CMD, get active zones. Those are up. sysctl dash a grep for IP forward. IP forwards on for net IPv4. What other ones did we set? We set the firewall values. So history. We set it to masquerade and forward. We set the zones correct. Those zones look right. 160's there. Let me think what else is getting there. Real quick, we're gonna try one thing. We're gonna stop the firewall just to take that out of the equation for a second. Now we're getting through. Okay, so I need to figure out the firewall part of it, but let's check to see if we can get the connection up. Because, you know, this is one of these things where if I know the configurations are right, and if I know the settings are right, I'll remove a component of security to see if there's something wrong there. So let me see, let's see. Let's go to like the Rocky test environment. I got over there. Okay, so the firewall is not set correctly on Linux router, and I'm gonna put that in my notes. So set the firewall to, I'm gonna say firewall turned off for testing. It was not allowing traffic through. Okay. Now, as far as we're going in the lab, so, but for now we can call this box is now turned off and completely ready to be pulled out of rotation, as is this one. So I can actually start turning off these two servers in my environment because they don't really need to be up anymore. And then I'm gonna take, I think I was telling you guys, I'm gonna take the newest of them. I'm gonna go look at the architectures on them and find the newest of them based on their not their BIOS, but when I go I gotta go find their versions of CPU, see what hardware is the newest of all of them. And I'm gonna keep a couple of them, but some of these like this one, this guy's definitely my oldest server in the environment. He's got 32 gigs of RAM. He's old, like I think he's like a 610 or something, old Dell. But I gotta find, where is that? Ah, CPUs. Here, I can go actually just look at the CPU from the models and see which one's the oldest. This is an old Xeon, so he's pretty old, as opposed to this guy who's an old Xeon, but he's a little bit newer version of a Xeon. And I think this guy's even newer version, so this guy might be getting repurposed. But this one's definitely going away when I get the boxes off of him. Okay, so the lab environment's back up at least. That's what's important for me, as far as that goes. For VPN and bond, so okay, yeah, good. X Shunya, you said, is the hiring getting back normal? So some of you guys know this is actually kind of a funny thing that happens with me. I'm constantly like tagged inside of LinkedIn as stuff as looking for work, even though I'm not looking for work. But I'm always looking around for jobs because, one, I have a bunch of college students, and two, because I just kind of like with the professional Linux users group, I'm kind of just wanting to see what's going on in the industry. So I'm constantly like getting tagged as somebody who's looking for work. So I'm always getting stuff. So Xshunya, to me, I mean, I think it still looks normal, but that's also from a guy who has work. So a lot of times when you have work, it's easy to find work. If you're looking for work, it can be a little more of a hassle to find that kind of stuff, and that's kind of a hard thing. One of the things I try to tell you guys is the best advice I can give on that is just try to have, try to be as ready as you can for when the jobs do come. Keep your feelers out there, but you got to keep your skills sharp. You got to keep working on this stuff. You got to feel comfortable enough to get this stuff running if you need to, that kind of stuff. But yeah, I wouldn't call it I wouldn't say like it's a bloodbath right now. I'm constantly seeing work, but also I think in some cases people need to probably update their skills. Like, while I'm a big fan of just getting in and doing Linux, I do think that like if you can't find Linux work, then you should be focusing on Linux with maybe like high performance compute or Linux with storage, because those type of jobs, I definitely see those out there. The people still have storage that they're running. People still have, you know, big research projects that they're running, and there's always people looking for that kind of stuff. That kind of work's always out there. You know, now, has it changed over the years? Sure. Is it going to have more AI involved? Yeah, I mean, I have AI stuff coming in through the NOAA projects that I'm on that I'm like, okay, I mean, it's interesting. But am I still giving like the user training next week, or well, in 2 weeks, I think, for all of our like users on the system? Yeah, I mean, we still typically have to have a person sitting there giving training and showing people how to move around in the system and stuff. You know, in 10 years, is that going to be all probably automated assistants? Yeah, maybe. But you're probably still going to have, I don't know, you're still going to have some people touching stuff. I tell people all the time, like, we've had the ability to fail over and fail back between systems for like probably the whole time I've had this career, and we still don't do failback automatically. Even though we've had that capability in systems for 20 plus years, probably almost 25, we don't do failbacks, like, because you don't, the system doesn't know all the other things that are involved with, well, maybe we wanted to do some testing, maybe we wanted to test stability, and systems would just fail back as soon as they saw the other system was up. So there's all these other things I think that kind of come into, I don't want to say the human element, but it's like there's other decisions that kind of have to be made sometimes, or there's other things that have to be considered. As far as like, remember when people were making fun of for years like 6 fingers on a hand whenever AI was doing something, and it's because the AI can draw the fingers, but they don't know what the fingers are or what they're for, or, you know, that kind of stuff. And it's the same kind of idea here, right? It's going to have to understand all these other like business components that are going on before it can make decisions like turning things back on in an environment. So anyways, all that to say, I think that there's always, like, I've always thought that there was command line work. Like, I think command line work's going to still be there for people, but I've also been accused of being an eternal optimist, so, which I think is hilarious for anybody that knows me. I don't think I'm completely optimistic. I just think that most of the time I try to trust that there's some good stuff going on out there. Okay, so let's do something real quick before I turn this node off, because I'm going to start turning these nodes off in the environment. I want to capture what they are. So I'm going to go here and I'm going to grab this. So where am I going to put this? I guess I'll put it in, I guess I could use OneNote, or I could just use a new document somewhere. But I kind of want to grab the speed of these things and the versions. Yeah, let's just do it. Let's just do it here, and we'll just throw it in a little home lab note. So general Linux, we'll add home lab, and then servers. So we'll call them XCP ng hosts. And we're just gonna grab a couple pictures here, so it'll look like this. I'm just gonna throw these in a notepad off screen just so I have them. So this is XCP ng HQ. Right. He is going to be here. And then I'm going to go grab this other one here. Here. And he is going to be same thing. Let me grab the same image, but for this guy. Get this out of the way, because then, so now that I have that information and I feel comfortable with that, I'm going to go turn these off. And what I probably should do, let's shut him down. I'm gonna grab my little trusty notebook here. Some of you guys know I love an engineering notebook. I have a notebook. I always have my this is a brand new one. I put the new filler in it because the wife got me the fillers. So I'm always writing in my engineering notebook. I'm gonna write down his name. So he is XCP. I let the system generate the names too. He's XCP ng You guys are probably wondering why I'm writing this down. You're going to see here in a second. And he's HUQ. HUQ. NEUQI, right? And I'm going to go mark when I turn him off here in a second. I'm going to go grab, because I actually don't know which box he is in my home lab. We're going to shut him down. He's going down. And then I'm going to go take a quick break here. Let's see. What could the break look like? We could go to cozy scene. That might be kind of funny. Hold on, let me pull up my hourglass. Let's put on my hourglass. Quick break. Say take a break and stretch your legs. Give you 10 minutes here. All right, I'll be back, guys. I'm gonna go check this box out real quick. I think that's funny, by the way. I think that little penguin guy in the cold where it's 98 degrees here is hilarious. All right, I'm back. Alright, keep taking your break, guys, but I will tell you he was the bottom server in my rack. So that's all done, that's all out of the way. Feel free to keep taking a break. With my hand. I'll be back. Alright, I'm back. So I found that server. That's good. That's good. I found that server. So I will transition back to here. We still got a little bit of a break while we're waiting. I like to give people... I do that same thing with my college students. Like, I'll just brain dump on them for an hour and a half, and then they'll be like, can we take a break? I'm like, yeah, I guess so. You guys need a break. But that server's off. I found it in the environment, so I know where it is. I'm going to turn this server off, too, while I'm sitting here. So I'm going to shut him down. I mean, they're just old boxes. I'm not really using them. I'm going to use them for... The newer two are going to get thrown into Proxmox, and then I'll put them back into the cluster as Proxmox servers. So... that'll be good, but we've got that all going. Yeah, so we're turning him off, so let's go write his name down. XCPNG, and then he is Big New. I remember when I got that server. He's one of the few ones I actually changed the way that his name was set up a little bit. He's Big New. I'm gonna go see where he is in the rack. But then when I go to start decommissioning some of these out, I'll know. Alright, let me turn my camera off for a second. Alright, I'll be right back. Still on break if you guys want it. Alright. Alright, I'm back. Make this a little smaller here, probably. What am I missing? Face looks so similar to Hyper-V Manager. Which one? Oh, this is the old XCPNG. Yeah, this is what I used to use. This is when Zen got forked. When Zen got bought by Oracle, XCPNG was forked from the open source project as it was taken over. So Zen is a pretty popular hypervisor. It was used for a long time inside of AWS, but they recently went off to Firecracker a few years ago. So people that care about that kind of stuff, like under the hood, what's going on. There are some pretty cool projects with Firecracker. It's still out there doing stuff. I'm going to get this out of the way because, one, it's bright, and two, we don't need it. Proxmox, we don't need that part of it right now because that part of the lab is built, so it's good. We can kind of like check that off and say we deployed the router. We didn't get the firewall part of it working, but we got the forwarding part of it working. So, there's another couple of tests we should probably do. Let's go into here while we're still running. It's still break for people that want break. Let's go back over here and let's SSH. So we're in Werewolf, so obviously Werewolf's working. Let's SSH to Rocky 5 real quick. And then let's ping www.google.com. Let's make sure he can get out. Yep. Let's ping to 192.168.200.1, which is his internal interface. That one's fine. Let's ping 192.168.11.1. So we knew that the full connection was happening, but we're testing each next hop as well. You typically, like in troubleshooting, you don't test individual things if the aggregate works, but I just want to kind of make sure there's nothing going on weird in my environment. Penguin food porn on the big sheet. That's funny. Yeah, I set that up a while ago because like a lot of people will just have like silly little like hangout screens or like intro screens or whatever, and I'm no good at that kind of crap, guys. I'm not good at setting up like I don't know. I got all this cool stuff. Is that not gonna play?
You get nothing. You lose. Good day, sir.
I got all these funny things, and then I just never use them because they just don't pop up for me. But anyways, where I'm going with that is like the lab's fine. I think the lab's doing the things that it should for the home lab for now. That was one of the things I really wanted to get moved over, and then I'm going to do a write-up. I told the guys I'd do a write-up on what we did. Because yeah, turning a Linux box into a router used to be a very common task back in the early 2000s when I got into this. Like we would use Linux boxes for routers, but nowadays with security, for sure with security posture of company, you're never going to do that. Like you might do it just in like a dev environment to like make a like maybe do a test and test a path is working, and then make sure that like, you know, maybe you have two different environments blocked with a firewall, and then you put something in between so you validate that things are going through that path, and then load balancer is working a certain way or something. I don't know. That's like a use case I can think of for it. But for the most part, we would not do a Linux router in production nowadays. You know, again, 20 years ago you might. The main thing you might use a Linux router for like that is maybe like a SOX proxy or something, like some kind of proxy. But nowadays, most people, if you're doing anything with proxies, you're probably doing Nginx because it's designed to handle that. So and most people, when you think of proxies, you think of like VPN proxies, and almost always people think of proxies as forward proxies, meaning I want to pretend like I want to masquerade and pretend like I'm in France right now, so I do like a VPN connection that serves as a proxy, and then I get an IP address in France, and then it looks like I'm in France or whatever. People do that all the time. You might say, oh, that seems shady. You do that for your video games or whatever. No, people do that all the time to test that their connectivity is working from different parts of the world. There's all kinds of services that'll do that for you. But the more common way that we use as sysadmins and systems engineers and infrastructure people, we do what's called a reverse proxy. So the system sits there and takes requests from the internet and then sends it to any number of backends. A reverse proxy in practice tends to be called a load balancer. Most of you know, oh, it's a load balancer. But at the end of the day, the way the traffic is moving is what's called a reverse proxy. It just means something in front of you taking the traffic where it needs to go for the last hop. Let's see. So what else do we have? So what I was going to show you guys, I mentioned this in the lab, so I'll pull this up because I think this is probably one of the more fun things going on around here. Is one of our guys decided to put together a really good lab. We had all these other things we were working on. Let's just go here and say lab notes. And if you were going to take notes with me, you could. If you wanted to do the lab with me, you also could. It's free online. But we'll go hop in here. I'll give you guys a few minutes if anybody wants to decide if they want to do it with me. We're going to go to one of our guys put together a really good lab on Grafana Alloy. So we're going to do that lab. Don't worry, it's not going to be that bright here in a second. The brightness of this will go away here in a second. But one of our guys put together a lab. He didn't tell me I could use his name, so I'm not going to use his name. We've got all these different types of monitoring going on. And where did he put it? He put it down here. So here is the... I'm going to link it to you guys if you want it. It's Grafana Alloy Telemetry Agent, so that should link to you guys. Move this over just a little bit so it's like this. And this is, again, this is one of our Killer Coda labs, but again, it was put in by one of the guys in our Discord. One of our regulars. So I'm going to do the lab notes. I'm going to give, this is the link. And what are we doing, right? So what are we doing in this lab? It says that we are about to build So we're going to build a complete observability stack. And what we're going to do is Alloy to Prometheus to Grafana. And then we're also going to do Alloy to Loki, because it actually it handles the functions of Loki as well to Grafana. So those are the two things we're actually doing in this lab. And he mentions here, like, the old way was you had Node Exporter plus Prometheus and Scrape, and you had logs with Promtail Loki, and then you had multiple different formats to know. Yeah, so that's a lot to kind of know. And then now you just do it all with Alloy. You got a Prometheus exporter, a Loki source, and you have one config file. So here's the roadmap, Grafana plus Loki. So we're going to set that part up and basically have the infrastructure that this Alloy tool is going to work with. We'll set up Prometheus. Prometheus functions as our time series database, TSDB, in the environment. Then we're going to install Alloy, configure it, and verify that the data are flowing through the whole system. So I thought this was a pretty good lab. I did this the other day when he sent it over. How are we going to do it? We're going to use Ubuntu. We're going to learn apt, systemctl, and some configuration. And then there's some paths for where the log paths are. Now, the log paths change. If you're using Rocky or Red Hat type, so it's Red Hat based Linux, you're going to be var log messages and var log secure. So these map to var log messages and var log. But do you guys know that you could just go in and modify that to an environment and make all your servers talk the same way if you wanted to? So, okay, so anyways, and then there's a bunch of lab answer files. So I should be able to go over here. I'm going to make this bigger for you guys so you guys can see it a little better. I should be able to go to answers, and then there's a bunch of files in here that are all set up. So if I needed to go look at them later, or if I am just clicking next, next, next and not really understanding, I can go read what the files are there. Okay, so that's good. That's all the stuff up front. And then in Killer Coda, right, that's the free website here. If you guys didn't know, you can get in Killer Coda. You just need a login, which is typically just like Google. I just log in with my Google account. They've never even sent me like an email. You can pay them, but you don't have to pay them. It goes right here. You can extend with a paid plan. But I've been using them for like 4 or 5 years now, and I've never paid them anything. I just build labs out there, and people use them and stuff like that. So, again, if you guys want to do this lab with me, feel free to. We're just going to walk through it a little bit. If you're running it outside of Killer Coda, you can create a folder, and then you can copy in the assets from it. Okay, copy in the answers, and you can set it up. Now, if you're doing it outside of Killer Coda, you're going to want to have a server that can handle. I mean, obviously, you're going to be running everything on one server, which is typically a pretty big no-no. But right, because we want to separate servers by function nowadays. But anyways, let's see what this is going. So, what are you building? Before Alloy could send anything anywhere, you need places for the data to land. Okay, so we're going to set up Grafana and Loki. Grafana will work on port 3000. That's true. Loki will be on 3100. Those are configurable, but those are the defaults. So, okay, good. Why Grafana's apt repository? Well, because then it's already in there. They're part of the official repo. And Loki is installed as a standalone binary under op Loki. So we're going to do that. And otherwise, you can download Loki if you needed to, which I think he shows you how to do. What to expect? Grafana will prompt you to change your default password. We'll do that. And then all that stuff. So let's go look at how we would do this. So we would set up apt. These are just some simple things that we need, so some dependencies before we start. And then we're going to download the correct Grafana key, their GPG key, from their website, and we're going to put it into a file called user share keyrings grafana.key. That's important because then when we say use that keyring as the signed GPG key for the repository right here, when we build the repository, that's what this command is right here. Then we say to use that key. Now everything that we pull down from the Grafana site, we got the key separate from the Grafana site. Now everything we pull down from this Grafana repository needs to be signed by that key, or our system won't use it. It's another. It would be like if I said, "Hey, I kind of know what you look like, but next time I see you, when you introduce yourself to me, go ahead and text me to my phone number that I'm going to give you, and then I'll know for sure it's you." Let's just say I couldn't remember your face, or I really wanted to trust. Like if you remember. Parents, well, if any of you guys were around in the 80s and 90s, parents would always have like a, they call it like a secret word for their family. So then if somebody's like, "Oh, your parents are in the hospital, come with me quickly," you'd be like, "What's our secret word?" And if they didn't know it, then you wouldn't go with them. You know, it's like a stranger danger thing. I don't know. Apparently kids back then got kidnapped a lot more or something. I don't know. But anyway, so we can do an apt update. So that's going to go grab metadata, and then we're going to install Grafana. So look, the first one will do all the metadata downloads, make sure everything's good. And then we're going to download Grafana from the page and make sure that we have Grafana running. Leo Inquisitive said, what's the best way to merge two synergistic repositories for a unified framework? For me, I mean, for my whole career, I only do repositories that are official from the vendor. So you say, well, you know, synergistic or whatever. I imagine you mean you have some other repository from somewhere. I've always thought of repositories as either, there's really two for me. There's the supported ones, which are external by the vendor, and then there's my internal trusted ones. That's the way that I deal with them. And then you say, well, how would you merge them? So my life, I have a whole thing on this, but everything external comes into a centralized repository for us. We're either doing that with Pulp if we're doing it on our own, or we're doing it with Satellite if we're paying Red Hat. And then now that's our internal trusted, and maybe we freeze that at the beginning of a month. So we download all the packages from whatever repositories. I don't care how many repositories we have. They go to one place. Then we set all of our dev servers to pull those packages, and we pull down whatever we want. We test them through dev for 2 to 3 weeks. Then we move them forward to our test QA systems, pull that down. So that frozen in set of patches, it does not change. It does not ever grow. It can be filtered down, but that all goes to our dev environment. We take out anything we don't want or anything that's problematic, and then we move forward to test QA, and then we move forward to prod. But that's the way that I've always merged. It doesn't really matter like what's coming down the pike. It doesn't matter, like, I think of it like a big Plinko machine. It doesn't matter what you give me. I'm going to take control of it at some point, and then that's going to be mine. So my life cycles are always, every month I pull down and sync all of my repositories, and then they become life cycles for patching through the week. So hopefully that answers the question. But yeah, if I had two repositories giving me different BS, typically I would go with the newer version of whatever software packages, and then typically, well, back in the day we used to have to merge the x86 and the x86-64 conflicts, so that's another problem. But nowadays we don't really use x86 anymore. You might still run into it every now and then, but for the most part I only use x86-64. So I don't know, hopefully that makes sense. I don't use, and professionally we don't use open repos for things. You may install an EPEL, which is extra packages for enterprise Linux, and maybe like put a Grafana or something. Like in this case, we're using actual Grafana supported. But if we were doing this out in the industry, we would probably only be doing this in our dev environment to validate. And then once it was good, we would say, okay, now we're going to get their supported packages, and we're going to, deal with, some Grafana licensing, probably pay them in some way. And then we would have an official repo. But even with that official repo, that's not open to my whole environment. I only pull that down and freeze it, and all my servers point to that. I never do external repos for any of my Linux environments. That's the biggest no-no in the world. Well, when I say biggest no-no, that is the biggest way to, in the inelegant way of saying it, to step on your dick. That's just the worst. I mean, or to trip over your own 2 feet, or however you want to say that. It's not really an elegant way to say it, but it's like, you're going to probably shoot yourself in the foot and mess up the whole environment if you're bringing. Anyway, so that's my thoughts on that. Hopefully that's clear as mud. Let's turn on Grafana. Now, when we turn on Grafana here, we're going to do a daemon reload. So the system's going to go read all the systemd files. There are some new ones. And I was telling, this is actually something that I had told our user about. When you do this, Grafana takes about 10 seconds to start up. So when you first run this, Grafana doesn't respond. The port is not open yet because the service is coming up still. So if we wait about the time it just took me to talk about it, there's Grafana listening. But when you first run this and you first start Grafana, it needs about 10 seconds. So we might do a pull request and change that. But Grafana is going to be open. So now we can go here and we can look in our lab environment at only my instance of Grafana. This is a new instance of Grafana that never existed until right now. And I can go in there and I can change. I do want to change the admin username and password. So, okay. We're going to change the password to something super secure, like 1, 2, 3, 4, 5, 6, 7, 8. So that's now coming up, and now we've got this new version of Grafana that never existed before. Thanks for the insight. My problem, I've been heavily dependent on LLM and trying to build an existing frameworks to avoid reinventing the wheel. Yeah, Leo, I would just tell you, like, so for me in the systems world, I have to control everything that comes into my environment, right? Like when I run things operationally. So yeah, if I can have a central place where only that downloads and then that becomes our source of trust in the environment, it really saves us a lot of trouble on our systems. Because then everything's being filtered through the environments. It's very much a CI/CD pipeline, but for lifecycle of packages. Because I mean, I had a boss years ago. He's a good friend of mine still, but he and I would get into it, and he'd be like, "Why is patching so hard for you guys? You know, we tested it for 2 weeks, and then we send a prod, and this doesn't work. You know, and it's like these things break and those things break." And I'm like, "Look, boss, we're doing like hundreds of packages from hundreds of different sources. Yeah, they were filtered through Red Hat to work in general environments, but we're doing specialized things with Java and this and this. And even though we tested in the lower environment, a lower environment, like your dev environment, is like a deflated version of your real environment." And you say, "What do you mean by this, Scott?" What I mean is you can't test to production levels. There's no way to test in production levels. And you say, "Oh no, Scott, I'm real good with Burp Suite and I'm real good with K6s. I can do a lot of use cases and really stuff." And I go, "Yeah, but you can't emulate what a user is going to do, guys. You like build this perfect web page and you'll have one user go right here and click 45 times in a row and break it." And you're like, who would have ever fucking done that? That's like beyond the edge of a use case. Or they come down here and they grab and they drag like this until the page breaks. And you're like, I didn't think anybody would do that. But users will do the most ridiculous stuff. We used to say if you make something idiot proof, they'll make a better idiot. But we were really talking about users, right? Oh yeah, I've seen the weirdest things ever. And I don't even do web stuff. I'm just saying, like, I understand test cases and stuff. So anyways, I don't know where I was going with that, but yeah, users will do weird shit to you. So let's go back over here, right? I'm in the environment. We saw that this will open that port for us. Now we're going to install Loki. So we're going to make a directory in op Loki. If you guys don't do a lot of operational work, if you just play around with Linux, which, by the way, perfectly acceptable, go hang out in our group. We've got all kinds of people that just do Linux for fun, but my goal is to get you guys the confidence to do this stuff professionally, because I think most of you can't. If you guys just watch me work in my home lab for the last hour, you're like, "Fuck, man, if this guy can do it, I can do it." I agree, you probably can, right? Most of you, if you do this stuff for fun or whatever, you can definitely do it professionally. So where I'm going with that is if you don't do this professionally, you don't know that opt tends to be where we put third-party tools. So I'm down in opt Loki, and that's a good place for us to drop some third-party tools. So in this case, we're going to run the Loki server, and Loki is a API endpoint for logs. You just throw logs at it. You throw just unstructured text data at it if you want to. But it's really nice for logging. So now we're going to download Loki. So we're going to go get this very specific version, 297, because we know it works. We're going to unzip it in this environment, and we're going to make it executable. So ls-l, right, in the environment, and we see that it's executable, Loki, Linux AMD 64. Now, the other thing we need to do, so now we've got that thing sitting there, and I could just do a ./Loki and try to run it, but it's probably going to break over everywhere fantastically. And the reason is because there's a bunch of configs we need to give it to run properly. So we're going to download all those configs, and we're going to actually move them in from the answers directory. So let's go look at what actually happened in our environment. So here's our Loki config. Whoops, Loki.local config. And it's going to say, well, we're going to listen on 3100. That's a default. And we're just going to sit here and throw our file system down in temp Loki chunks. Now, if you had like an off store, like an off, I don't know, someplace else you wanted to store these, you could. Maybe /temp is not the place you want to store that. In fact, professionally, I would probably put this in its own specific directory. Maybe even down in opt temp or something, or opt Loki temp chunks, because I want all that stuff in the same location. But this is the default it comes with. Just know that this is not normally where we put something like that. All right, and then there's just some other default values and stuff like that that are there. Also, this was commented out, or we uncommented this because we did want to disable the reporting, because we don't want to send up information from our organization to the Grafana team. Now, might you want to do that in your home lab? Sure. In a professional environment, you typically have security postures that say you can't do this. You should not just be sending general data out of your environment. That is a very bad security practice, right? So anyway, something to think about. Also, I think I missed it, but thanks for the follow, Ray Rami. Hopefully this stuff's useful to you. So now we got that running. And now we're going to make sure that they're both active. We can just do an ss-ntulp, and we can grep for -IE, and maybe look for 3000. Well, that's an OR, 3100, right? And then now we see that 3000 is open for Grafana and 3100 is open for Loki. We could also have done it like this if we wanted to, right? And we could search for Grafana or Loki, and then we can see that, yeah, the listeners are open for this service or whatever. Hey, Zorgal, how's it going? We're just going through the new lab that one of our guys built, right? And I'm purposely not saying who it was because he didn't tell me I could, so. But we do have now, so now we've got a couple of services running. Grafana is our endpoint visualization tool. Loki is an API endpoint that we can just throw stuff at. And in this environment, that's all we're doing. Could we, here's, what else could we do? We could only allow things to talk to Grafana that have the right certificate. We could only allow things to talk to Loki that have the right certificates, and then we could generate and build our own certificates in the environment and do all that stuff, become a zero trust monitoring. Cool. That's all like good for people that want to dig with that later. For now, I just want to get us set up for the systems, right? So we're just building the base systems out and making sure it all works. So now we're going to build the Prometheus time series database, right? It's going to go and scrape all the data off when we have a configuration for it. So we're going to read a little bit what we're expecting, and here's the solution. We're going to add a user for Prometheus, and then we're going to make a directory varlib Prometheus. Now, something I just said earlier, that most everything goes in /opt if it's a third-party tool. Prometheus wants to live in varlib Prometheus, so that's the default place that it kind of wants to go, and it wants to set most of its configs in etc Prometheus. You can do that if you want. Professionally, I tend to do /opt Prometheus and then maybe etc Prometheus underneath that. However, when we're just setting it up in the lab, it's fine to do. These are the defaults is where I'm going with that. Could you modify that for your own environment and because you want to do it a certain way? Absolutely, you could. Okay, so it's something to think about. We're going to download the binaries. Remember, these are locked in at a certain version, so 2420. Those will always be there. And then we're copying it over into, so user bin Prometheus is going to be our executable. And then we're going to change everything in varlib Prometheus to be owned by that Prometheus user. Well, that's going to be very important in a second here where we actually turn on the service. Okay. Oh, I didn't show you guys how we turned on Loki. I'll do that here in a second. We're going to copy in the configurations, and then we're going to look at them. And this is the Prometheus service, how it's going to start. It says it's going to be the user Prometheus, and it's going to do that execution, like we talked about. And it has to be able to go read and write into these directories. So reading etc Prometheus that's not going to be blocked typically. But it wants to be able to write into varlib Prometheus for its actual database. So it needs to own that. That's why that ownership had to change up here. Because that user is going to try to write into that directory with this process. So, okay. Then we're going to start it up, and we'll make sure that it's all running. It's going to take a second to come up, so you might want to wait. And then when you're ready, give it 10 seconds or so. There you go. You see it's listening. So now this server is pretty. It's a pretty chonky server. It's got a lot of processes running on it, right? One of the things we want to do, I want to show you guys this. So system CTL status Loki from earlier. Loki's running, but how was Loki started? This is one of my favorite commands to show you guys. Is cat. You can now see that Loki was just started as a single startup when the network came online. Opt Loki AMD 64, and then there's our config file for Loki. And it is that local config file that we looked at. So Loki by itself as an executable doesn't know all of these values. It might take some defaults, but we want to give it those extra things. Dreamin' Nid, hopefully this stuff's useful to you. That's the experience talking. How do I build existing open source resources, merging them into one like Graphy, Code Graph, and Context, and so on? Leo Inquisitive, I don't necessarily do that stuff. We do have a lot of guys down in the Discord that are professional coders, but I don't do a lot of that stuff. And I don't, for if you want to get involved with open source, what I always tell people is first get on the mailing list, see what people are working on, kind of find out where you can get involved. 2, you can always download the repository and start looking at the code. A lot of times you can go look in the actual Git repository and you can see the issues, and you can start fixing issues in your own branch and then having them reviewed with pull requests, and then people will either add them or not, depending on what else is going on. But that's what I would start on if that's where I was going, but I don't necessarily do that. I do work on a couple of open source projects, but I don't do a whole lot of other stuff. I don't run any of my own ones really, except for like the labs and some other stuff around here. But mostly I just keep systems working, right? Like I'm a systems engineer at the end of the day. So, okay, so I just wanted you guys to see that. So we started Prometheus. Everything's running in our environment. If we wanted to kind of step back and look real quick, we can do ss-ntulp, and we can see, I can make that a little bigger for everybody. Yeah, well, we'll just do it like this. We'll grep, and then we can look for IE. So E is going to allow us to do extended regex filtering if we wanted, but let's just look for Grafana or Loki, or now we just put on the tool called what was that, Prometheus. Let's just look at those things. So we have Grafana running on 3000 like we expect, Prometheus on 9090 like we expect, and then Loki on 3100. It's also got 9096, but we don't really need that right now. 9096 I think is their GRC, so if you wanted to send direct messages over there you could, but we don't necessarily need that right now. So now we're going to put on this Alloy tool. So Alloy is the new piece, and the Alloy piece is sitting in our environment. We're building something very similar to this. We've got Loki and Prometheus and Grafana, but what I used to have back in the day was Promtail Agent and Node Exporter. This is what my home lab actually looks like. This is my home lab monitoring. But these are being aggregated down into one tool called Alloy. So now we're going to go set up Alloy, and I want you to guys think Alloy will push logs or will allow scrapes from Prometheus. So Prometheus has to know and scrape from a node, and the Loki, or now the Alloy configurations, need to know to push to Loki. So we're going to set all that up right here. So we're going to go look for that in our configs as we kind of build this out. Okay, so it's going to collect host metrics, replacing node exporter, tail log files and replace Prometheus, and then later receive traces, profiles, and more, but that's not in the lab. Configuration lives in there. They have a thing called the river language. That's the first time I'd heard about that, but now that's something I can go work on if I need to. Oh, also, guys, by the way, Discord is always free. I want to mention something real quick. We got a bunch of events and stuff up in there, but we are almost to 5,000 users. We are getting real close to 5,000 users in here. In fact, the bot's welcoming people. We're probably 1, 2, 3, 4. We've had a few people join today. We're probably at about 49, 70 or so, if I had to guess. Actually, we got a little command here. See how we're doing. We're 4963, so we're getting real close to 5,000, and I'm sure this bot's going to do something wild when we hit 5,000. Fisherman runs it all. That says Fisherman Guy Bro wrote the Fisherman Guy bot. Very clever, I know. I'm trying to convince him to start streaming again. We need to get all these guys streaming more. But now, let's see if we can install package but configure it later. Alloy package ships default configs so the service can start on install. Yeah, but that's not going to point to anything. That's true. What we call that is like out of the box. And I tell you guys all the time, the usefulness of an engineer tends to be we need to set the things up the first time. Because I tell you all the time, if things just set up out of the box, they wouldn't need us. The salesperson would just set it up as they like close out the sale, you know. But they need us to configure things for an environment. So, I mean, this isn't a great way to say it, because you never just want to be a config monkey. But a good engineer does understand the config files he's on. He also understands why he's doing the things, and that's what makes him more than a config monkey. But you do need to understand what's going on here. So why add Alloy? The journal requires membership in Journal D. Without it, so let's go ahead and install Alloy. We already have that repository set up earlier, but we can update it for metadata, right? Metadata will pull up, and then we'll install Alloy. If we didn't have that key, or if that key was busted, it wouldn't accept this. It'd be like, hey, that repository requires a signing key, but you don't have that key. Or if that's been modified in some way, it would be like, yeah, bro, I'm not installing that. It doesn't look like what I expect it to, right? Yeah. So it's just a good way to think about it. Now, since we're adding a user, so we see, let's say ID Alloy, Part of what it did was it created a user for itself. That user exists, and then it's got some groups and stuff. We can add it to the systemd journal environment, but it also looks like it already did that, so it's already there. But we could also do a user mod and make sure it was there. So ID Alloy, systemd journal, cool. But their initial installer script did do it, so that's kind of good. But that's probably like an older way, probably from the notes or something, but that's still good to make sure that you're in the systemd journal. If you ever need to go modify that manually, you VI etc group, and then you / to, let's say, Alloy, or systemd journal, right? And then now here you see that the user Alloy has been added to the end of it, right? Everything that's read, so if you do like an ID Alloy, that's actually being read from etc group, right? Some of those values are coming from etc passwd, and some of them are coming from etc group in real time, basically, as you read it. So that's good. Now we can confirm the binary. We can check to see if Alloy version is there. Everything's there. We could, if we needed to, we could say which. You can always say which Alloy, and you would see that it's in user bin Alloy. So cool, it's configurable. We've already run it, so we know that the system found it in one of our paths, but that's definitely in our path because it found it when we said Alloy version. Okay, that's cool. We got it there. Now we need to turn it on, though. We need to get it running correctly. So in this lab, we're doing Prometheus exporter, remote write to prom. So we're turning that on so that it can send. Now, is this sending? Well, we're going to check to see if this remote writes to Prometheus, because if it's writing, that's actually a different model than we normally use. So I'm going to have to check that out. That'd be interesting if that's writing to it, because that's actually the non-preferred way to do that with Prometheus. And then we're going to do Loki source journal and Loki source file, and then we're going to write out to Loki. That is the preferred way to do Loki. Okay, so here's a bunch of the configurations that we're going to see, and then we're going to go and look at what's going on in there. So let's go look at our solution. We're going to copy these in. Well, let's go look at our config here. There was our cat of it, but here's this, says Prometheus exporter Unix localhost, so that's going local. Scrape metrics, getting information and forwarding it to this server, okay. And we're doing a remote write, okay. I mean, we're gonna have to check into that, because unless Prometheus has changed their configurations recently, they typically want to scrape, but this is a push. So what I was showing earlier where I said Prometheus scraped, typically Prometheus pulls or scrapes every 10 seconds, but this is actually, this Alloy is pushing, so it's a different method. So that's going to be interesting to think about. Once we've got that in place, right, and we've looked through it and stuff, it's going to validate that the formatting's all good. That's useful. There's no errors, and then we'll restart Alloy and make sure that it's running. Okay. We can go check to make sure that it's doing all the writing, and we're not seeing any errors like a crash loopback. So I saw this the other day. No errors, nothing breaking, good. So if that's all good, then we should be able to set up inside of Grafana those two data sources, Loki and Prometheus. We could have already done that. And then now we're going to be able to go and look at our queries and see if everything's kind of working. Here's what the solution looks like if you want to go see it. But we already have Prometheus up, so we're going to, or Grafana up, so we're going to go look at it. We're going to go to connections. We're going to add a new connection, and the first one we'll go ahead and do Loki, right? I want Loki. So we'll connect Loki. And inside of Loki, give it a second here. We're going to say add a new data source, and then in here we're going to make it 127.0.0.1 on port 3100. We saw that port earlier, so that's cool. And then we come down here. We didn't set up any of that TLS stuff. We're fine with that. We're just going to leave it open for now. And now one of my favorite things about Grafana is when you say test, it'll actually save and test that it can read from that data. So that's cool. I'm going to come over here. I'm going to do a new connection, and I'm going to make this with Prometheus. Right? Not Prometheus Alert Manager, although there's all kinds of other useful things, but Prometheus is what we want. We're going to add a new data source, and we're going to use the Prometheus at 9090, 127.0.0.1 9090. So that's our Prometheus data source. And if this can read, it'll say right here, hey, we were able to query the Prometheus, and then that's there. So now if we went and looked at our connections, we should see two connections. View our configured ones. So there's Loki locally, and Prometheus. Now those could be other places in our environment. Like in my home lab, it's my different servers doing whatever they're doing, right? Okay, so we got that. Let's go back and look over here. We can go do some actual commands on the Prometheus if we want to. And then we can import a dashboard and go look at it. So this 13639 is a useful kind of Loki dashboard. Let's say I want to do dashboards. And I'm going to say new. When I do new, I'm going to import this dashboard right here. I'm going to load it. This comes directly off of the website for that. We're going to take the default Loki that we just configured, import it. And now we have no data yet. But the data are available inside of the apps here. You just need to know your queries that you have. So the queries could be syslog, auth, or systemd journal. So let's say that I did auth. And here's all my auth logs right here. So let's make sure in real time real quick that if we were let's say I was lying to you and this was just a made up like log and I made this whole thing up. Let's go over here and let's say on this node, let's go on this node real quick. Let's say that I wanted to validate like that we're for sure doing this. So I'm going to say for I in, and I'm going to do sequence 1 to 1,000, right? I'm going to do user add -m, and we're going to go, I'm going to use Leo inquisitive $I. We're just going to make a whole bunch of Leos. Now I'm going to sleep for 3 seconds, and then I'm going to say done. So I'm just going to make a bunch of users. Every 3 seconds, we're going to make a user in this environment, right? That's all we're going to do. Boom. That's going to just happen in the background. And let's go watch our log right here. And is somebody adding, or are these showing up? This should be refreshing every 10 seconds. Let's let this refresh every 10 seconds. Is there a user being added in this environment called Leo Inquisitive over and over and over and over again? Right here. Should be. There it is. Yeah, look at these guys. Let's make that a little bigger so you guys can see them. Every 10 seconds, bigger. Yeah, there's up to 7. There's 11, right? I don't have my cans on the keyboard, guys. I'm not making this up. Well, I am making a lot of this up. But the point is, it's like, here's the... When we talk about like plumbing an interface or plumbing something up, it's this idea that, and I grew up in Arizona. There's a lot of, we used to have these natives out here called the Hohokam, and then there were these canals, but also we build a lot of canals. Phoenix, Arizona has a lot of water. People think it's a dry desert. It is, but we pipe in a lot of water through these canals. And where I'm going with that is like, I grew up with like irrigation, and I saw irrigation in big cow fields and stuff like that when I was a kid. So, you know, they would open up the thing and it would run the water down through the canal, and then they would open up and it would flood their fields. And that's how I feel like with a lot of this stuff when I look at it. It's like, we've got all the tasty data over here on the server. The server knows all this stuff. It's got logs and stuff. But then we can feed that data out to like an ingest point that can hold it. So we're bringing data in, we're storing it somewhere, and then we're presenting it. But basically you've got to prove that you've plumbed it across. So this is going to make 1,000 Leo Inquisitive users over the course of however long we leave this up in our environment, right? And it's going to just keep going over to Loki. Now, from there, like this is very important to note. Just having monitoring like this is good, but this is not an intrusion detection system, right? This is not detecting anything. It's also not really a SIEM solution, or SIM as some people call it, which is security events and information monitoring. This isn't really that, because it's not actually making any decisions. Maybe I know whenever I see user add in that auth log, somebody's making a local user, and that's bad in our environment. We don't want that. We do all our stuff through LDAP and trust relationships and stuff. So users should not be added to my system directly. So all of these could be triggering real events, right? And could be setting us up and all that kind of stuff. Give me flashbacks dribbling over it. That's funny. So anyway, so this is the lab here. I thought it was a really good lab because if you're very familiar with the node exporter and what used to be called Promtail to send logs, now you're doing it in one place, and then if we hit check, it'll say, did I not? Oh, let's see, did I not set everything up? Oh, I gotta do this, Leo. I gotta hold on. I gotta make a lab test message, right? And then I need to come over here, and I'm gonna switch this from off to what's the other one? Syslog, I think. Syslog's the other one. And then I should be able to see. There's my Alloy lab test message. But let's make that a little more. Let's make this a little Linuxy. Let's do it like this. Let's say Alloy let's say while true do, and we'll do that. Alloy lab test message, and let's put inside of there date plus percent. Let's say F %T, and then let's see if that works. Sleep to done, and Alloy lab test message Scott is not lying to chat, right? Let's see if that shows up every 2 seconds over here. There it is. But yeah, then every 10 seconds that's going to come up again as Scott is not lying to chat with the date, right? So it'll have the date tied to it each time. So give it a few seconds, a few more of those should pop up. I could be lying to chat, but at least I'm lying to chat in a way that still is technically sound. All right. So, clear as mud, right? Let me see what the wife says. Hold on, she took my truck earlier, so gotta check on her. Let me message her real quick. All right. Yeah, so I think that lab's pretty good. There's a couple of things, and me and the creator had talked about it. There's a couple of things that could be cleaned up in there, but for the most part, I mean, it works. It looks like it's doing all the things that you might want. Let's hit check. I think the last thing was I had to actually hit that logger, so it probably checks for the logging in there. Some concepts, push versus scrape. So Alloy pushes metrics. Classic node exporter setups are scraped. That's very true. Alloy pipelines are declared and configure Alloy not in Prometheus YAML, so that's good. It's that river language or river config language, so it's just another version of you know how you're doing it. Ubuntu logs, they differ in rel, so secure, and it's typically in rel it's messages and secure, right? So auth log is similar to secure, and syslog is secure to similar to messages. So when I say secure, yeah. Alloy needs systemd journal group membership for journal log. That's perfect too, because then you can see if things are breaking as they come up. I actually didn't look at that. Let me look at that real quick. What was that? So that was should be one. Oh man. Oh, what was it? Systemd. What was that? Systemd-journal. So now I'll get all the journal logs. So this is good. So let's say, you know, your restart these. So these logs. So you say, what are systemd journal logs? These are the logs when you go to start, like HTTPD, and it doesn't start, right? And then you got to do journal-xeu and then look at the service name or whatever. Well, what if you could see them all here? What if you could see services not coming up? Or what if in here you were watching, you know, because again, this is all going to Loki, and Loki is just acting as, you know, for all intents and purposes, it's actually truly an API endpoint that just sits there, but it could be treated like a pub sub or what we call like an event bus. You could be watching it for events from other systems. So you could be watching for servers that rebooted, because servers that reboot are going to start all their services up. So maybe you watch for a service to trigger that normally wouldn't trigger in the environment, and that lets somebody know that something's happening that shouldn't be happening, right? This is one of these things where I tell you guys, like, the engineering side of something is super easy. Well, hold on, let me back up. People have a hard time with the engineering side of things, but let me tell you, engineering is this straightforward thing in that we can give you an exact set of steps and you will build something exactly like us, right? That's engineering. If I can give you an equation or a set of steps to do something the same way every time, and you do this lab that was put together for us, then you're like, okay, cool. That always works. Good. Now there's an art to it as well. This is where we say engineering versus art. If I can give you a set of steps and everything perfectly works, that's engineering. But if you say, well, Scott, what should I monitor? And what should I alert on? And I go, well, or you're like, what's the balance of how many times something has to happen before I trigger an alert to go out of a system? And I'm like, well, there's thresholds, there's all these things, but tuning that down actually starts to be an art. And you say, why do you call it an art instead of engineering? Because I can't tell you exactly. It's going to be more to like your environment. I can show you all kinds of things on how we set upper and lower control limits, and hey, we expect 5 events an hour, and if the instantaneous rate over the course of 5 minutes goes higher than 2, so it changes, then we do something with it. Or there's all kinds of things. There's derivatives and stuff that we can do to determine that a change is occurring more rapidly than we expect. But where you apply those, well, we could just apply them everywhere, right? But we'll burn all the CPUs out in our system well before we, like, you know what I'm saying? We're trading off from like work. So you say, well, what's the trade-off, Scott? Because we could do everything. And I say, yeah, you can do everything, but these are finite systems. They can only do so much in 1 second. So you go, well, so wait, that's not engineering? And I go, no, that's the art part of it. That's the stuff that we spend our whole careers getting better at. You ever hear how doctors never say they arrive. They're always practicing medicine. I mean, they're really confidently practicing medicine, but they're still just practicing. That's what a lot of systems engineering is. Like, I can show you how to plumb all these systems up and pull the data, but what data are important, that's where the money's made, right? That's the people that are valuable, right? The engineers are also very valuable. Don't get me wrong, being able to plumb these systems up. Like this set of steps right here for a company that's not doing this yet, this would be a valuable project for people to, if you learned how to do this and went and did this for companies, they would need this. But anyways, yeah. So that's my kind of little thing on this. So where you could go, there's some more ideas of what you can do. And then you can also do eBPF profiling and Alloy. So that's going to show you kernel calls and system calls and that kind of stuff. Oh, he did say who he was. Okay, good. So I wasn't going to say who he was, but he put it right there. So now it's on him. So I think he's in chat too, or he was in chat a little while ago. So, but yeah, if you guys like labs like that, we'll get more of these made. I've got more labs to make too, but also some of this shows me I need to up my my markdown game, so some of my stuff's a little better. But we'll start going through. We're also going to be cleaning up older labs and stuff like that as well. So yeah. And guys, like Prolog, this is the thing. Like get in here, get plugged in. I think Zorgel knew some Linux when he came around, but he's learning more and more as he goes. And then he goes and he writes up a really good lab on this. From here, he could start doing. We had done some alerting labs. Now he's getting all the data in, and we could start setting thresholds for where things alert if we wanted to, right? For certain things, like somebody does a user ad and we start alerting on it and that kind of stuff. So yeah, this is again, this is a lot of that. I don't know, that's not bad. Let me see, hold on, let's go look at let's go do, I think, let's see if we do have PIDstat on here. Let's go 110 real quick. Let's see what PIDstat's showing us, kind of what's going on. Alloy's running every time. All right, let's look at what he's doing. We don't see his memory here yet, but we'll look at that here in a second. Let's just see how the box is doing with Alloy. So over the course of the last 10 things that we looked at, what's Alloy doing? He's really chilling on user and system calls. That's not much. Then here's this PID 6836. Let's do a VM stat. Let's go look at how this stuff's going. It's MP stat I need. Hold on. We'll do MP stat next. I think I have MP stat on here. Let's go see what's going on here. Yeah, this box is chilling. Where do I have? I definitely have that somewhere. Can I look at PID stat for just a specific? He's not doing much, I can tell you that. But I think I can dig in with, what is that called? Those are systat. I need for that one. Yeah, here we go. We do PID-stat-R to look at alloy, but I want to see what's his PID again. There he is. Let's look at him for. I think I can look down PID stat for specific. Oh, G process name or I should be able to do. That do it? And then can we do like 110? So we'll just watch him for a little bit and see how he's doing. It looks like he's kicking off every few seconds and just not doing too much really. I mean, if we're looking at what's going on there. Grafana template ID 2747. But it won't do it per process, right? Won't give us any specific. I mean, we know the box is mostly chilling, but for that one process ID, we could do that for looking for alloy. And he doesn't look like he's doing. I mean, he doesn't look like he's doing too much. It looks like every 3 or 4 seconds it turns on, and or maybe that's only when we're catching it. Oh, hold on. Let's see. Oh, yeah, it just wasn't catching it earlier. Yeah. It's not doing much. Yeah, he's not doing much in the big scheme of things. Just kind of sitting there chilling. I don't think I have. Oh shit. Oh, we don't have it. See if we have an 8-top out there. Let's put 8-top on it. 8-top's a good one for. You want to see everything that's kind of going on. I sometimes grab stuff with 8-top. Yeah, I know. I have to look stuff up all the time. I don't remember everything. I do actually have. I do have Prometheus monitoring windows for sure. In some environments, yeah. You can export with all kinds of different tools, guys. You can do all kinds of stuff if you want. Prometheus is just, guys, Prometheus is just a time series database. It'll scrape anything. It's like Ron Burgundy with the teleprompter. It'll read. It's like, what did you ask it to read? It'll do it. Alloy's down here chilling. This is what it's using. So, yeah. ATOP's not bad for that. I use ATOP sometimes for troubleshooting systems, but you got to be gathering it in real time. Like, you got to gather it all the time. You can't go back, guys. You know, these data points are ephemeral. If you don't get them, right then you'll never get them. You'll never get that data back. So, what did I miss? Zorgal said build trend and Grafana since metrics are flowing. Yeah, absolutely. Yeah, so so what I was saying about Alloy pushing is they tend to say that push metrics is not the one that they want to use, but so Prometheus can scrape that, but Prometheus does allow pushing to it. It's just not their preferred method. Let's see. So there's a trade-off there. One, it's super easy because Prometheus is just going to get pushed to from all of your clients, so you don't have to go configure that separately. But two, it's yeah, it's still, I'm pretty sure it's still not their default. Like, they still don't want that to work that way, and I don't know if they have it. They still say scraping is the preferred method. I'm pretty sure. Obviously, they still have scraping first. Lots of scrape info. All the configurations, all the things that you can do by default. They might have it up here. Do that live. Metric types. Getting weird phone calls on the weekend. Not interested. Yeah, I don't know. They had it somewhere. I was studying for my PCA a few years back. I just never went and took it. Anyways, there's all our info. All right. So that lab, I mean, I think that lab's pretty good. It'll show you a lot of the basics. If you're coming from already understanding how that whole stack works, it'll give you a lot of information on the newer way of doing it. If you're not coming from that stack, I think it'll still give you a lot of good info. So either way, it's going to show you that, kind of what's going on. Yeah, so Zorgal, one of the things about Prometheus, and one of the reasons they want to scrape every 10 seconds is because it allows them to do that up metric. So in my home lab, if I go to, I think it's 192.168. Yeah, here it is. They explicitly say that this up metric only works if they're scraping. So if I just do up, hit execute, they see how some servers are up 0 and up 1. So 0s are down. So these are infra nodes that are down. And then, oh man, I got a bunch of stuff that's down. But if it's a push metric, it doesn't automatically do that. Pushed metrics, they don't keep an up or down state for servers. So they prefer to scrape, because then if they can't scrape the server, they call it down. And then there's a threshold for that. I think it's like 3 scrapes or something. So after 30 seconds or whatever in most Prometheus instances, because most of them scrape every 10 seconds, they would go, so like if I turned off security, if I went and turned off this box here, so we could actually, by the way, we can do this whole, watch, we can filter down like this. Oops, no, get out of there. Get out of here. I did not mean to do that. Right here. Oh, mother effer. Got my hands on the wrong part of the keyboard. All right, let's just go, where's he at? Here's admin lab, right? So, my fucking keyboard. I swear my keyboard's changing shape. Let's copy this damn thing. Go here. This right here, if I execute this, should show me that node being up. Now that happens to be port number 55 happens to be Rocky 5. He's 55. So we're going to let's I was gonna do it right here, but let's actually back up a second. Let's turn him off at the actual. Let's turn him off here. We're gonna go turn him off in Proxmox. I was gonna turn him off there, but I'm gonna turn him off here because I want him to not boot back up. So I'm gonna stop him. Just stop Rocky 5. Boom, you're down. And right here, if I keep hitting this execute here, you're gonna see that go to 0. Right under my hand right here. Right above there. You're gonna see that go to 0 here. When it can't scrape him, load time, there he is, he's 0. He can't see him anymore. He also disappears over here. Where's he at? Here. He stops showing up in here, which actually is a behavior I don't really necessarily like. It doesn't show him as down, he just stops showing up in here. So that's not great, because if I was showing this, I would rather him be like red and down. But these are dynamic, so these are only nodes that are up that show up here. So I might have to modify this to all nodes. But anyways, where I'm going with that is, now let's go turn him back on. So we'll come back over here. Let's go physically, and the reason I didn't just reboot him, because some of you are like, why didn't you just reboot him? He would have been back up so fast that we could have missed it. So let's turn him on here. And some of you guys know he's a werewolf system, so he's going to come up stateless. He's not going to know who he is. He's going to do a DHCP call right here. Who am I? He's going to find out from werewolf that he is a Rocky 5 server based on his hardware address. He's going to pull down his kernel and his init RAM FS, and he's going to boot, right? That's how the lab works. That's like a very standard config nowadays in HPC. That's a very big high performance compute. He's back up. I come over here. He's back. Well, in a few seconds, the service will be running for Node Exporter, because we built that into an overlay in Werewolf, and this will scrape. And when it scrapes, that's going to turn back into a 1. There it is. It's 1. He's back up. He also shows back up over here immediately. Right here. Immediately. So Rocky 5. There he is. He's back. And his uptime is 32 seconds. Right? He's only been up for a few seconds. So, anyways, yeah, I don't know what we were talking about Zorgle there, but that's my understanding about why they always want you to push, is because they want to be able to say, hey, he hasn't scraped, he's down. And then they can alert on that. Now we can use that for alerting. But if it's a push metric and it doesn't push, they don't necessarily trust that as a node is down, right? Like he's reaching out, but then he's not there anymore. They don't necessarily use that as a way of saying, well, I scraped and I couldn't get a hold of him, so now I call him down. So I don't know. It's something to mess with, something to see. Yeah, you could throw everything to Grafana for sure. Okay. We can pull all those off. Those are just what we call labels, right? Labels just filter down what you see out of a Prometheus query. So, all right. What else? So that was the lab. I can throw that up in. I don't need to throw that up anywhere. I think you guys that followed along probably got it all right. But yeah, that's what we were doing today. We cleaned up the home lab. We got things where we needed everything. You can have Prometheus scrape more often if you want a smaller tool. Oh yeah, you can do that. Absolutely. Yeah, we can completely configure Prometheus if we want. I mostly have out of the box in the home lab. In the home lab, I mostly do out of the box stuff. I think I left it. It looks like the global scrape is 15 for me. Default, I don't know if it says that. I probably have an older version of Prometheus as well, but it said default was every 1 minute, but it's been pretty faster than that. Rules every 15 seconds default. I'm pretty sure it's faster than that now. But yeah, you can make that way faster if you want. You can also have your alerting and your alert manager, and then where you're going to pull your scrape configs from. I don't like to make a scrape config for every individual thing. I like to say, hey, everything that's in this directory that has a .json on it is going to be read. So everything in here, and some of these are from before, and you might say, well, why do you have individual ones for bunch from? Well, we were generating these with Ansible back in the day. So 192.168.11.198.json. This is the XCP. So these were the hosts for XCP-ng. But a lot of these got deployed automatically. So if we were over here, root, what's it, admin? I think I called it streams. And then code examples, yeah. Linux admin, and then down here, this was for a long time. This was where a lot of the Ansible in our home lab came from. And then if I looked at, I think it was called node exporter.yaml. So this was how we would deploy node exporter in the environment. So now I go down into roles and node exporter, and then if we go to tasks, here's how we would deploy. But what would happen as we were deploying this node exporter onto this was back when we had a lot more physical nodes in the home lab. One of the last things we would do is we would set a value for each of those files in Etsy Prometheus and the name of the server, or in this case the IP.json. So a lot of those other ones were automatically created inside of that Prometheus environment. So that Etsy Prometheus, that's where that was happening from. And Ansible was creating, we did this all by default. And then, oh, I didn't have anything in there for this one, but this was just how we used to deploy it. Nowadays, it's much simpler. You say, well, how could it be simpler than that? Well, now, every time a node comes up in Werewolf, oh yeah, he was dead. We use overlays now. So the overlay for node exporter, when one of those boxes boots, like Rocky 5 just went down and booted and came up, he comes from a stateless image. He comes from an image in here called, in his case, Rocky 9. So he's on the Rocky 9 images. And that Rocky 9 image is a very baked in set of stuff that's needed for those boxes, but not a node exporter. Node exporter wouldn't be baked in the environment. It may be specific to each individual environment, or I might want to take this image and give it to one of you guys for you to run in your Werewolf environment, right? So you might set up a node exporter overlay, so then the image boots up and then the overlay goes over the top and it gets these other pieces. And you say, well, what are those other pieces, Scott? So we go back to the overlay list and we look for -A for node exporter. And now these are the files that it's going to overlay onto that server when that server comes up. You guys just saw that server boot, come up, and then start talking to Prometheus. Well, the way it was doing that is right here. So Prometheus was always waiting to scrape it, right? It saw 0. It said, hey, nothing's there, buddy, nothing's there. But then when it came up and it could scrape it, it was because when this system came up, we can go look at this. So we can say overlay, and we can cat one of these files. So cat node exporter. Let's do the service here. There, and then all it's doing is grabbing the etcd system node exporter from this server. So if we do a more etc systemd system node, you can use your Werewolf server as like the source of truth, and all this did is it comes up. But actually, no, actually I take it back. That's where it's getting the link. So that's actually the that thing gets copied in. But this one is the one right here. This is the one that's special for it. Hold on. System. This one is specific to these nodes. Etsy systemd node exporter service. And this is interesting because the op.mount has to be there for this to work. Now, before we get too far afield, because people are going to be like, wait a minute, what the hell is Scott talking about? On this Werewolf box, if I were to do a show mount -e, he is exporting, show mount. He is exporting all of these directories, specifically opt, right? So opt has to be up on, if we SSH to Rocky 5, let's say, and we do a df-h on opt, you'll see that he is from there mounted. So then in here, node exporter is the only thing that's in there, and it's got these things. Well, if I were to just do a normal boot like this, what would happen is as the network came online, node exporter service could try to start, and that'll break all over the place. When I set this up, it did break all over the place because we needed to wait until op.mount was available on this node, well, in the Rocky boxes, because if not, they wouldn't have this location because it's actually being shared from the Werewolf server. So you might say, well, Scott, that's kind of convoluted. There's a lot of moving parts. Yeah, there is, but it's kind of a nice way to do this. Hold on real quick, guys. I gotta take this call from the wife. All right, guys, I'm back. Sorry about that. Zorgo, push-based efficiency better for firewall network configurations where central Prometheus cannot reach the agents. Yeah, that's definitely possible, Zorgo. Yeah. I mean, you may have, so either way, when you're, whether you're scraping or pushing things, you typically have to open firewall ports if you have a lockdown environment like that. And like so depending on the posture of your organization, I was in an organization where PCI environments automatically got firewalled off. So you needed to explicitly request anything into them. So that could be, yeah. So this is one of these things like where do we do it? This is, again, this is another one of those places where I say, if it was something I could engineer, it would be an exact set of steps, an exact thing. But architecture in a lot of ways is an art. Where do you put, I mean, because we could also secure, all of this could be secured with zero trust, right? We could do our own private key, it's typically PKI's public key infrastructure, but we could have our own key infrastructure internally, have our own certificates authority, and only things that are supposed to talk to things do. And in that kind of instance, we could just leave everything open like a big open wall. But that's not typically the way that we kind of do it. So, yeah. So, yeah, Zorgal, it's really going to depend on what people can accept and what they can stomach. So print stuff so you can draw on situations. Yeah, look, Ken, I'm a very big fan of drawing things out. I actually like that about Excalidraw, is I can put everybody in here on the same Excalidraw and we could draw things and figure out, hash it out as a team how we think something's supposed to work, and then go build it, right? I think that's kind of valuable. So yeah, I think that's pretty good. But then now, so here's the next question. Do we want to change this in the home lab? In fact, I think that might even be my message of the day was Linux in the home lab, updating our lab with Alloy. So we did that lab and we saw how to do it. We could do the same basic thing. Really what we would do is Werewolf would become the initial setup. Werewolf would get down in opt, it would get a configuration for node exporter. Actually, so it's funny, I don't have my Rocky boxes currently doing Loki yet. So I don't have Loki set up ever since I moved everything over. So I do need to set that up so I can get all my logs going over there. But if we're going to go net new, why don't we just do Alloy with that, right? And then we could just turn off the Prometheus part of, or the node exporter part of it, and push everything into Prometheus. So that's definitely something that we could do kind of next in the lab environment, right? And get some of that functionality back for our monitoring. I think that would be good. And then we'd like to probably explore that eBPF stuff too, because that's good, that's valuable to kind of see what's going on in the environment. So, and then this funny, I didn't notice this when I first wrote this, but that Rocky thing, if you scroll up a little bit like this, and you only see the Rocky like that, kind of makes me think it's like flipping me off. And you only see the Rocky like that. I think it kind of looks like that, right? So, I don't know, anyways, that's funny to me. We set those up the other day. Let's see what auto looks like. Auto 5. We use the old, that's our older one. And then, what was Hammer 5? We did Hammer. So we did them different ways just for fun. Just to kind of mix it up a little bit. So, That's not meta. You might set up alloys with their eBPF. Yeah, I think that's actually probably one of the ways. Because I use Falco for that. Because Falco has some pretty good eBPF built in. Falco's by the same guys that wrote Wireshark, by the way, in case you guys didn't know. But they're really good for system calls. And typically Falco is used. It's part of the. So here I'll show you guys. If you ever look at what is that, the cloud native roadmap. This is like the most busy. That's a CNCF. Yeah, this is like the most busy slide deck on the web right here. The CNCF landscape. If you've never seen this, but this is like, if you want to know, this is to that point of like make versus buy versus adopt. If you wanted to know, like, well, if we're gonna adopt some open source in our environment, but we don't want to spend we're going to adopt open source in our environment, but we don't know what's going to still be around. These ones up here that are like the incubating or the graduated, they are definitely going to still be around. So you can mess around with some of these other ones, but the big ones are the ones up here. So where I'm going with that is Falco is down here in the security and monitoring. Yeah, Falco is graduated. So if you guys have never heard of Falco or looked into it, it is very big for CNCF and monitoring syscalls coming out of your containerized environments. So your Kubernetes environments, but you know, your pods and your containers inside of there. And Falco shows what syscalls are happening, but it does eBPF tracing. I actually got to meet the guy who wrote it at a Kubernetes thing out here in Phoenix a few years back. But yeah, all of these, some are still incubating, but Keycloak is big. Keycloak isn't going anywhere. But if you were like, well, I don't know if I should recommend that to the company because we might not be able to get support. No, all of these things are definitely going to be supported going forward. So you're going to be able to find that kind of stuff. Yeah, it's like the map of Middle Earth. Yeah. If and I love J.R.R. Tolkien, but man, if he hadn't passed away, there would still be more books. He wrote so much. For people that only watch like the movies and stuff, you guys don't know that guy had maps and books and languages and yeah, that stuff just kept going, man. But anyways, yeah, that's the landscape if you've never seen this. All right, the environment's done, but we got a lot out of it. Home lab's good, so we did a lot with that. All right, I haven't really talked about it too much. I mentioned it a few times earlier, but you know, we got Discord where you guys can hang out. We are up to almost, like I'll show you guys again, we're up to almost 5,000 members. We're at 4,956, so we're getting there. Probably here in the next couple days, because we probably get about 10 people a day hopping in the server. And you guys are welcome to hang out and do as much or as little as you want in there. I encourage people to get involved. All the events here are free. There's nothing that costs you any money. There's a big event coming up in August. We do on our anniversary, so I think this will be our, what is this? This is our 12th year officially as a group, but 7 on Discord. And these are all the people that are coming to talk to you guys, right? I'm going to kick it off with Why Engineering. That's a talk that I've given quite a few times. Hold on. That's a talk that I've given quite a few different times. We've got somebody come and talk about thinking like an attacker. Burninator is going to come and talk rail system security again. Jared's going to talk data analytics. We're going to have a late night hangout because typically when we're done, people are like, well, what am I going to go do now? So we're just going to hang out in the server and try to break it. I'm actually going to try to we need like a couple more boosts. So I'm going to ask some of the senior guys like to boost the server because I can't boost the server anymore. It won't let me. It only lets you boost your own server so many times. Something like that. I don't know. But if I can get them to boost it, we'll get better audio quality because we've broken Discord quite a few times over the years. And I think it's hilarious, but you know, sometimes people are doing some serious business and trying to get stuff going. So Stovepipe's going to come. He's got a really good GitHub, but he's moving his GitHub over to that one of those newer SVN things that people are using. And he talks about RHCSA. He's got a really good study guide for people on that. So people that want to get their RHCSA specifically for version 10, which is the newer one, that Sending Grounds is going to come and talk. This is the one that's got the most people interested in it because Sending Grounds works for the big Fang type. He works for one of those big guys, and he's going to talk systems engineering and AI for you guys because he's a systems engineer on massively big scale systems, bigger scale systems than I've even worked on. So I've been on systems, 15,000 nodes and stuff, and that's a fucking drop in the bucket compared to the stuff he works on. So he's definitely one. He's got the most people right now. I've been kind of checking. like where everybody's at. He's got the most people signed up for his. What's he at? He's got like 16 people, but we'll have hundreds come through that day. We have typically hundreds, maybe even over the course of 2 days, like over 1,000 people. And again, I just want to see if we can break Discord most of the time. So these rooms are supposed to be designed for up to 500 people because it's like a one-way conference. So yeah. So people have plenty of time to get in there. Yeah, this right here, it's just because people don't really check events very much. But when it gets closer and I start talking about it a lot, we'll have probably over 100 people for each of these signed up. But we'll have people just flowing through the whole time. So, yeah, and it's all free. So just come out and do whatever. There's also a lot of, places to hang out and get plugged in and hopefully meet people that are thinking about the same stuff as you guys are interested in, doing Linux and that kind of stuff. So, all right, let me go and let me throw this back up so you guys can see chat. Let me throw this back up so you guys can see the home lab, and I'll probably drop off. I didn't really get much. I mean, the notes here, I didn't really go through everything that we did, but that was kind of like my quick notes. That's also in there, so we probably won't do anything with this. But when I come back on, and I will probably start it all over again, maybe tomorrow. I don't know if I'm gonna be on much tomorrow, but we'll probably do, like, one of these days I'll do a session that's just like I think it takes about 6 or 8 hours to go through all the Socratic Linux. So Socratic method is a way that you think about how you've learned something and what you know about a thing. So we'll do the Socratic Linux again because people tend to really like that. But a lot of times recently I've been working on the home lab because you guys, if you're in the Professional Linux Users Discord, you have access to these boxes. All these, all the auto boxes, Hammer and Rocky boxes are there for you guys to use. So it's something to play with, something to get some skills on Linux if you don't have them. You also have Killer Coda, which is like just one of the best free websites there is. It just drops you in a Linux shell, lets you go start doing Linux. You don't have to pay them nothing. You just drop into a Linux shell. That's a pretty good deal if you want to get into this. So, all right, I'm gonna drop off here. Let's go find somebody to raid on the Twitch side, on the YouTube side.